Hello and welcome to part 6 of the VR character series. Today we will be adding projectile weapons to our project. I am also no longer going to speed up the implementations and will do them while commenting. This is a new way of recording for me, but I will give it a try. Additionally, I have seen in the comments that some of you are having trouble making the project work. Therefore, I will share the whole prototype project with you for free. You can download it from the first link in the description. This way you'll have a working project and you can use the videos to get an understanding of how it works. And if you're new here, you aren't forced to watch every past video just to have an up-to-date project. I also do this because there is a lot of static meshes to set up and changes to existing code. Of course, you will find a link in the description to every asset used. This way you can still do everything yourself if you want to, but won't have to waste your time if you are just interested in a working prototype project. Now, let's start by organizing some stuff. In the VR character, let's organize our functions. Because right now, they're all in here and it's hard to tell what belongs to what. I will start by organizing the grabbing functions. We do this by selecting the function. Then over here on the right in the details panel, we can give it a new category called grabbing. Now you see here, you have this little tab that we can expand, where it is part of now. Now we can just simply drag these other functions in here. So I will drag in update grabbing and stop grabbing. Now the rest of these functions are basically just basic character functions. You can also add them to a category of collision maybe, but I will just add them to character. And unfortunately you cannot select all of them at once. So yeah, you're somewhat forced to drag them in one by one. Now down here in the variables, I also want to add the right grabbed actor and left grabbed actor to a new category, also called grabbing. Great. Next, I want to adjust the physics asset of our character. So I will select our mesh, open our SKM Manis skeletal mesh, and on the top right, go to PA mannequin. Select everything except for the hands, and then disable the collision response. This will have the effect that these bodies will no longer collide with our world. However, back in our VR character, we can now select the mesh again, come down here to our collision settings, and re-enable the block collisions for our physics bodies. Last time we disabled these, so if we walk into an object that we want to stand on and that simulates physics, we won't kick it around. Now, by disabling all of these physics bodies, especially the feet, we will no longer have the problem of pushing that object around. Since our feet are not simulating physics, they have an infinite mass, so they would just easily kick around any physics object. With this, we can still interact with that physics object with our hands, but not with our feet. Back in our VR character, go to the physics constraint. Now, last time I realized that I messed something up with the rotation, where we had to turn our meshes upside down. So for example, if I get, let's say, the baseball bat, there we go. You see it's turned upside down. I don't know why I didn't realize this earlier. However, we can fix this and actually revert this, so we don't need to turn everything upside down just to grab it properly. I also found a way to grab something consistently by its socket, so more to that later. So back in the character mesh, turn the left physics constraint on the x-axis 180 degrees, and for the right physics constraint, we only want to turn it by 180 degrees on the x-axis. Positive or negative doesn't matter. I will turn it to positive, just so it looks a little bit nicer. Then we want to go back to our skeleton, so select the mesh, open the SKM Mani skeletal mesh, and up here, select this skeleton, so we open up the skeleton. Here we want to add a socket to our thumbs. These are the sockets where we attach shotgun shells to that we grab out of the ammo box. So here, select the thumb, or say L for example, then add a socket, When you select the socket, we can add a relative location of 3 and -2. So we see it's a little bit below the thumb. I also will rename the socket to ammo underline phone underline up. Then we do the same for the right thumb. So right click, add socket, select the socket, and here we want to invert the offset that we set before, so -3 and +2. Of course, you can adjust this as much as you want, but that's the offset that works for me. And again, rename the socket to ammo underline phone underline R. There we go. Next, we want to add subfolders to our weapons folder. So in here, I will first create a folder for our melee weapons. And I will move our create a melee weapons into here. I will leave the weapon base class out here because it is not only for melee weapons, it's also the child class from our projectile weapons. Then next I will create the folder for the projectile weapons and another one for magazines. You can move this into projectile weapons. I will leave it out here. It's whatever. In the magazine folder, we want to create another subfolder called ammo. And in the ammo folder, another subfolder called bullets. More to this later. Now, like I said before, we don't only need to flip our weapons, meaning right now they are looking the wrong way, which I know is inconvenient, but we only have to flip them once and then it's all good from there on. Meaning we can just simply import our weapons upright and it's all good. So this is the last time we have to change this. So in our fab folder or wherever you store all of your assets, I will search for static mesh. So I get all the static meshes. I can simply drag them out. And then on the top left, I will change from selection to modeling. Go to the X form and then simply turn each of those around by 180 degrees. So they're still facing the X direction, but they're now facing up. So the way they should be. Now I can just hit Fake Transform. Do this for every static mesh. This is also already done in the prototype project, which is available for download. Right now we can delete those. That has been saved. And of course, since we've changed these, the orientationalities are wrong. We can open these, go to the viewport, and now we can just take these two, rotate them by 180 degrees, and move them up. And now it should be at the correct position again. Let's do this for everywhere where we need to adjust the penetration hitboxes. It doesn't make sense to rotate it because it would just rotate it around the axis, which would put it into the exact same position. The baseball bat we can leave because here we don't have any penetration, so these two components will be deleted anyways. And for the X. Yeah, this is good enough. There we go. Now that we have flipped our meshes, we can add the handle bone socket. So let's open up our meshes, go to the socket manager in the top right, and add a socket. And we will call it handle underscore bone. Since we already set the origin of this mesh to the exact location where we want to grab it, we can just leave the socket location where it is. Or of course, if you want to adjust it, you can do this. Last time when I tried doing this, I didn't know that you can update the relative location of the physics constraint and its grabbed components, but now I found it out, so we can do this with sockets and not the painful way that I did it before. So I will just go ahead and add these sockets, make sure to always name them correctly, and yeah, that's about it for this part. Now we can continue. There we go. I know this part was inconvenient, but it's the last time where we have to do some fidgety stuff like this. Back in our weapons folder, we want to add a new enum. So right-click, go to Blueprint, and Enumeration. We call it E_firing mode. Here we will define the different firing modes for our projectile weapons. We will add 4 enumerators. The first one is called single, the second one semi-auto, the third triple, and the last one full auto. Now what these do, the first one is if you only want to fire once, but not have the weapon reload itself. For example, a shotgun, where you have to manually move the slide every time. Or a bolt action slide. Semi-auto, pretty self-explanatory. It's, for example, a Glock pistol or a rifle, which is in single fire. Triple fire, of course, is supposed to shoot 3 times. And full auto, the weapon fires until you release the trigger again. Then let's go to our interfaces. Last time I created this BPI damageable. I'd like to rename this to BPI damage interface. Because in a bit we will create another interface, and I just want the naming convention to be all the same. But before we create the new interface, let's go back into our weapons folder, to our damage types, and add another one called Projectile. We add this type so whatever we hit knows it's been hit by a bullet. Now let's go back to the interfaces and create a new blueprint interface called BPI Weapon Interface. This interface consists of 11 functions. The first one is called Fire Weapon. Pretty self-explanatory. When you press the trigger, you want to start firing the weapon. The next function is called Stop Firing Weapon, meaning if you release the trigger and the weapon is in full auto, it will stop. Then we want to be able to change the weapon's firing mode, so create a new function called Change Weapon Firing Mode. Then the next we want to be able to release the mag. So release mag. We create an interface for this, so no matter what kind of future weapon classes we create, we can always easily call these functions through the interface and won't have to base everything off one singular base class. Since, for example, a grenade would use a different base class than a baseball bat. Next function is called move trigger. And here we want an input called alpha, and it's of type float. With this parameter, we can input our trigger finger's input and alert the weapon's trigger from one rotation to the other. Then we also want a function for initializing moving slide. So start moving slide, stop moving slide, and move slide. Now, again, the first one, of course, is when you grab the slide. Here we usually want to stop the weapon from being able to fire. For example, if it's fully automatic and it is already firing, we want to stop firing. Stop moving the slide, we want to check if we are able to release the slide. For example, on a pistol, when you stop grabbing the slide, it usually goes forward, except for if the mag is empty. And with the function move slide, we will update the slide's location. Therefore, we will also need a few inputs. First one is the motion controller, so we know where the hand currently is. So type motion controller component. And the second parameter we call slide grip bone. This is a type name. Here we will input which socket our hand is supposed to attach to. Because I haven't really found anything online where they used a full body with physics to attach the hand to a weapon, for example, while gripping it or while pulling the slide. So I had to come up with my own idea, and I realized that you can use physics constraints to always make the hand move with the slide. I know this isn't very intuitive, but it's basically the only solution I found to this problem. And I also tried using the animation blueprint, how you would usually do it, and with reverse IK, but since we are simulating physics, there was always either a delay between the weapon and the hand. So for example, while the weapon was moving correctly, the hand was always a little bit behind, or I wasn't able to move it to the target location. Since most of the tutorials I found only used the hands for a VR character and not a full body, it could simply just attach the hand. But in our case, this isn't possible because our skeletal mesh is one whole mesh. So if we would attach it, we would attach the whole body to the weapon, which obviously we don't want to. Then the next function we need is set main hand. Here our input is called hand, and this is of type E-controller hand. We use this to set the weapon's main hand. We need this for applying the recoil to the player. And then we also want to be able to set secondary hand. And here the input is the same, called hand again, and of type E-controller hand. This should be filled in automatically since we just used the value on set main hand. And the last function is called get slide component. We don't need an input, but we want to have an output called slide component. And it is of type primitive component. With this, we can return any weapon slide without having to cast to any weapon class. Let's compile this, and now we can close the weapon interface. Next, we want to go back to our VR character. In here, we need some variables and some functions before we can create our weapons. So in the variables, let's add a new variable called right recoil offset. There we go. This is of type vector. And I will add it to the category weapon, and then one of these pipeline things, these straight lines, another space, and then recoil. You can use this to create subcategories in a category. Then we can just copy this. I don't know why it won't automatically copy it within a category, which is a little bit annoying, but well, I guess we'll have to deal with it. This is called left recoil offset. I can simply drag it in here. Then we don't only want linear recoil, but we also want the weapon to rotate. So the next variable is called right recoil pitch and float. This is of type float. And of course, here we also want this for the left hand. So the left recoil pitch. We will use a timer to only learn the recoil when it's necessary, so it doesn't have to be in the tick function. And for that, we want a timer interval. So let's call this recoil lerp timer interval. This is also float, and after compiling, we will give it a default value of 0.1. So we want to run this 10 times per second. Then we also want to control the lerp alpha. So we'll create another float variable called recoil lerp alpha. And then we also need two timer handles called right recoil th of type timer handle. These will be our timer handles for the timers of our recoil, left recoil th. And we will also add these to the recoil category. Good, that's it for the variables for now. Then for the functions, we will create a new function called apply recoil. Now, if we create a category down here, it is also available for our function. So we will also add it to the weapon recoil category. I don't know why it's shown here twice, once with a space and once without, but well, I'll just leave it. In this function, we need 3 inputs. First, we want to know to which hand we want to apply the recoil. So this is of type E-controller hand. Then the next is supposed to be the location offset vector. Oh, and this hand is why we need the set primary and set secondary hand in the weapon interface. And the last one is the pitch, which is a float. The next function is called lerp right recoil. These are just sub-functions for the apply recoil function, so everything is a bit tidier. We don't need to pass any params here since we have our variables down here. Other one is called lerp left recoil. And then the next function is called lerp Recoil. This is again just to not have everything duplicated in these two functions. So we can just do the actual lerping in here. And here we have 3 inputs. First one being the location offset type vector. Then the next one is the pitch type float. And the last one is the recoil th, which is our timer handle. And very important, these 3 variables are all passed by reference. So make sure you see this star icon, which means it's passed by reference. Then we also need a function for adding the pitch recoil, so add pitch recoil. We need this function because I tried applying the recoil the same way as we do with the offset or with the linear recoil. However, I found it very problematic. For example, it got way too buggy. So we need to apply this rotation to our motion controller. This probably isn't the best way of doing it. It's just what I found to work well and consistently. Because again, otherwise the weapon sometimes would just fly through the room, or the recoil is not applied to the pitch, but to the yaw. Yeah, it was a bit weird. So this is what we will use for now. And this we will also call, if we go to our event graph, we will call this in our tick event. This is the only function of the recoil that we will call in the tick event. I know, again, it's not ideal, but it is how I managed to do it. And we need to add it every tick because the rotation of our motion controllers is reset every tick because it's reading the value of our motion controller that's being tracked in the real world. And the last function we need is called release grabbed actor. This function has an input called grabbed actor of type actor. Now this grabbed actor does not need to be passed by reference. And we need this function because if we are attaching a magazine to a weapon, as soon as it attaches to the weapon, we want to release of that mag, because otherwise we would still hold on to it and things once again would get buggy. I'm going to move the release grabbed actor function to the grabbing category. We will add this implementation later, since we need a couple of variables, but we will add those at a later point in time. So we will get back to this. What we can already implement, though, are the recoil functions. Let's start with the apply recoil function. First, we want to switch on hand. Then, if it's the left hand, we want to set the left recoil offset. And here we want to get the left recoil offset. There we go. And then we want to add the location offset. But I'm not going to drag this out because this will just create a whole lot of blueprint spaghetti. What I'm going to do, I'm going to search for location offset, and we can get this as a variable. So this, in my opinion, is a bit cleaner. Then next, we're going to set the left recoil pitch. Here it's the same. We will get the left recoil pitch and add the pitch. Next, we want to get a branch, and we want to check if the left recoil timer handle is valid. Only if it's not, we want to set a timer by function name. And in here, for the function name, we are going to input the lerp left recoil function, which we have created over here. Just make sure that this name does exactly equal this name. So I'm just going to copy paste it, and then this should work. For the time, we will get our recoil lerp timer interval, and we want it to loop and max 1 per frame. Then we set our left recoil timer handle. That's it for the left. Then for the right, we are going to do the same, but for the right. So get the set the right recoil offset, get the right recoil offset, and add the location offset. There we go. Set right recoil pitch. So get right recoil pitch and add the pitch. And again, this actually we can just copy paste. Here, of course, we want to get the right recoil timer handle. And here we want to call the lerp right recoil function. Timer interval is the same. Now it's the same. And here, of course, set right recoil timer handle. Then next we can go to lerp right recoil. All this is basically calling the lerp recoil function and then input the right recoil offset, the right recoil pitch, and the right recoil timer handle. And of course, do the same for the left. You're probably asking yourself why we call this here and not just call this call the lerp recoil function here and input the parameters. For whatever reason, you cannot pass parameters to a timer function in Blueprints, or at least not that I know of. I know you can do it in C++, but in Blueprints, I didn't find any solution to this. So that is why we do it like this. Now it's probably just a workaround and not an actual fix, but it works for now. And if I find a better way of doing it, then I will let you know. So next to the lerp recoil function, where we first will lerp the location offset. So lerp vectors, lerp vector, and we want to lerp it to 0. The alpha is the recoil lerp alpha. Then we want to set ref by ref var. This will set this value. This is also why we pass it by a reference and not just by a regular value. Then next, we're going to get the pitch and set by ref var. And here we want to lerp a float, A being the pitch. And again, for the alpha, we'll just input the recoil lerp alpha. This, and at last, we want the launch. Here we want to check if the location offset that we just set is nearly 0. And unfortunately, that same node doesn't exist for floats, at least not that I know. And we want to get the pitch and nearly equal to another float, which is 0. And as the tolerance for both of them, we will add 0.1. You can play around with this value. I will choose these numbers. They work for me. That's the whole meaning of the project, so that you can experiment around with it. Now, if both of these are nearly 0, we will set the two values by ref var. So this one by var and set it to 0, 0, just to make sure that it's actually 0 and won't remain at 0.1 or close to it. And at last, we want to get the recoil timer handle that we also passed as a reference and invalidate it. Clear and invalidate timer handle. There we go. That's it for the lerp recoil function. While editing and testing, I realized that I forgot to set a property. Here for the recoil lerp alpha, the default values would be 0.2. That's what I'm going to use. If you increase this, it will lerp faster. The highest value you can add to this would be 1. Anything higher than that won't lerp it faster. We would just instantly snap it back. So I say around 0.2 should be fine. At last, we want to add the pitch recoil. So we will get the right motion controller, the RMC, and want to add local rotation. Then we will right-click on the delta rotation pin and split the struct. On the pitch, we will input the right recoil pitch. And then, of course, do the same for the LMC. Again, I did have some issues with always applying the rotation to the pitch, even if the weapon is sideways, which is why I've resorted to doing it like this, just adding the local rotation to the motion controllers. I know it's not perfect. It works for now. Again, if I find a better solution to it, I will let you know. Great. Now we can start with our weapons by creating a bullet class. Go to the content browser, blueprints, weapons, magazines, ammo, and the bullets subfolder. In here, create a new blueprint class of type actor and call it BP_bullet base. First thing to do is to disable the start with tick enabled. Since we don't need the tick in this actor, we can save some performance by disabling it. Then we will add a static mesh. Make it the root and call it bullet mesh. Then we also need to add a projectile movement component. And we're going to set its initial speed to 10,000. The initial speed is how fast the bullet will fly. And if you scroll down a little bit, we want the velocity to be 1 at X and 0 at Y and Z. This is in which direction the bullet will fly. But since we will set its rotation based on a socket on the weapon, we can leave this as it is. Next, we're going to need some variables. The first variable is called damage and is of type float. I will give it a default value of 50. Then the next is called lifetime and is also of type float. I will give it a default value of 5.0, meaning if you shoot at the air, the bullet will despawn after 5 seconds. With this, we can avoid large performance spikes when you're shooting in the air. Then we're going to add a timer handle called lifetime th. And it's of type timer handle. We also want to spawn particles, decals, and play a sound on impact. Let's first add the Niagara system called impact particles of type Niagara system. There we go. The impact sound is of type sound base. And for the impact decal, we are going to use a material interface. At last, we also want to be able to create explosive projectiles. So we're going to add another variable called isExplosive. And it's of type bool. Next, we will create a function called destroy projectile. This function has one input called hit and is of type hit result. First, we will get a sequence. You can either search for a sequence or you can drag out this pin and then just press S on your keyboard and it will automatically add a sequence. On the first output, we want to get the lifetime handle, timer handle, and clear it. Then we want to get the hit result. You can create these by hitting R or searching for reroute node. Oh, no, I've ranked one too many. And we want to write the hit result. Send it, and get the hint component and create a new local variable called hint component. This local variable is only visible in this function, and it will be cleared after the function has been executed. And if this is valid, then we also want to get the location and create a local variable for it called hit location. Get the impact normal, create the rotation from x vector, and create another local variable called impact rotation. We are creating these local variables because we will need them multiple times in this function, and with this we don't have to drag out this to multiple nodes. And in the end, we want to also get the hit bone name. And again, create another local variable called hit bone. Next, we want to get the node spawn system attached. With this, we can spawn particle systems wherever we hit. And for the system, we want to get the impact particles. Attached to component is the hit component. And attached point name is the hit bone. The location is the hit location. And the rotation is the impact rotation. We want to keep the relative offset. And we want it to auto-destroy after it's done playing. And we also want to play a sound at location. For the sound, we will get the impact sound. And the location, again, is the hit location. This is what I meant by we will use this multiple times. And that's why I wanted to set these variables over here, because otherwise we would be dragging out all these lines over here, through here, and it would just get very messy. At last, we want to spawn the decal, also attached. Decal is the impact decal. Now the decal size, I'm going to set it to about 3. You have to experiment around with this. Depending on your decal size, Unreal Engine sometimes has problems spawning them. For example, sometimes you have to set the size to like 10. In my experience, it never worked when this decal size was set to 1. I don't really understand why. It doesn't even draw it very small. It just doesn't draw it at all. For some reason, for me, size 3 worked, 3 and upwards. So you'll just have to play around with it a little bit. Now, attach to component, we will get the hit component. Attach point name, the hit bone, location, the hit location, and the rotation, the impact rotation. If the hit component is invalid, we will first get a branch, and then we want to check if it is explosive. Because if it is, here we will spawn system at location. Since we don't have a component to attach it to, the location is the get actor location. The system, of course, is still the impact particles. And here for the rotation, we get the actor rotation. Now here, again, auto destroy. You can leave the scale. You can just leave this as it is. And of course, we also want to play a sound at location. The sound again is the impact sound. And the location is also the get actor location. There we go. Now we are almost done. All we need to do now is to call destroyed actor on the second output of the sequence. This is also why I added a sequence, because otherwise we would have to recombine these two here or add 2 destroy actor nodes to the end of these 2, and it would just once again get a bit more messy, which is why I do it like this. Now we can go to the event graph, and in here we need the begin play. In here we want to set a timer by event. For the event, we can drag this out and create a custom event. I will call it on projectile lifetime expired. I think I wrote that correctly. The time is the lifetime. We don't want it to loop, and we also don't need to tick the max once per frame. The return value, we want to set the lifetime of th. And if this is reached, we want to destroy the projectile, which is why in the destroy projectile function, we have this second check if we didn't hit a component to just let it explode in the air or just despawn it in the air. This also helps if you, for example, manage to shoot a projectile off the map where it wouldn't hit anything ever. You can be sure that it will eventually be destroyed. Now for the hit event, we want to select our mesh, right-click, add event for bullet mesh, collision, and on component hit. In here, we again will add a sequence. We want to get the other actor and cast it to the damage interface. If it is valid, we want to call the damage function. This is an interface that we added, I believe, in the last tutorial when we added the weapons, if I remember correctly. And for the amount, of course, we will input the damage. And then for the second output of the sequence, we will get the destroy projectile node and input the hit. And before we are done, we want to select the bullet mesh and make sure that its collision profile is set correctly, because right now it will block all. However, we want the collision preset to be custom. Collision should be enabled. The object type should be pawn, and we want it to ignore pawn and vehicles. This is because for the shotgun, we will spawn multiple projectiles which have different directions, and then the projectiles will hit each other, meaning they would instantly despawn right after firing. Great, that's the first class done. Next, we are going to create the ammo base class. Go into the ammo folder, create a new blueprint class of type actor, and call it BP_ammo base. Then for the root component, we also want to replace it with a static mesh. I will call it ammo mesh. We'll also duplicate it and call it shot ammo mesh. And select the shot ammo mesh. Go to the right, scroll down to visibility and set the visible to false. We only want this mesh to be visible after a bullet has been fired. For the collision, we can select both meshes, go to collision and set it as grabbable object. This makes it possible for us to also grab the shotgun shell. Next, we are going to add some variables. First one is the bullet class, and it's of type BP bullet base. Here, make sure to select the class reference and not the object reference. Then the next one is the despawn delay. It's of type float. And I will give it a default value of 5. And the last variable is called was shot, which is of type bool. Next, we are going to create a function, which is called set ammo shot. In here, we want to set was shot to true. And then set the visibility of the ammo mesh to false. And set the visibility of the shot ammo mesh to true. Then let's go into the event graph. And here we run a custom event called despawn ammo. And here we will get the despawn delay and set a delay. After that, we want to destroy the actor. We will use this function to start despawning the shell after it's been ejected from the weapon. That's it for the ammo base. Next, we are going to create the base class for any container that's capable of carrying ammo. So again, let's create a new blueprint class of type actor and call it BP_ammo container base. Again, disable start with think enabled and add a static mesh. I will just call it mesh. Then we want it to simulate physics, but you can see we cannot tick this option. What you can do is just add some skeletal mesh to it. I'm going to add the baseball bat. I will tick this and clear the mesh again. Now you can see the option is ticked and it will be enabled. You can, of course, also go to the event graph, get the mesh and set simulate physics and set it to true, but I will do it the other way. And down here in the collision settings, set the collision presets to grabbable object. Then next we want to add an instanced static mesh. We will use this instant static mesh to display the ammo inside of the container. Since instant static meshes are pretty optimized, we can easily add or remove instances and physically display how much ammo is left. Then for the variables, we are first going to add an integer called current ammo count of type integer. Then the next one is the max ammo count, also of type integer, and I will give it a default value of, let's say, 10. The last variable is called ammo class, and it is of type BP_ammo base. And here again, make sure to get the class reference, not the object reference. Now for the functions, the first function we are going to need is called the update all ammo instances. In here, we want to get the instance static mesh, and I just realized I forgot to rename it. Let's call this stored ammo. Let's get this and clear all instances. Then we want to get the current ammo count, subtract 1 from it, so we get the index. And then input this into a for loop. Hey, while testing this, I realized that I input this into the wrong one. This should not be in the first index. The first index should be 0. The last index should be our current ammo index. Next, we want to get the index as a string, so to string, and then get a string append node, and input this into the B input. In A, we will input the ammo _bone underline. We will come to this later. These are the sockets that we set up in the magazine mesh, where we will tell the mesh where the ammo is supposed to be. Of course, you could also somehow algorithmically spawn the ammo. However, with different ammo shapes, this is going to get very complicated. And I think even though this is a bit more work, this is probably the most practical. Then we want to cast this return string to a name, get our mesh, and check if the socket exists. So does socket exist? And we put this into a branch. Now we can connect this to the loop body. Now again, we want to get the mesh, get the socket transform, again from this one, and then we want to get our stored ammo and add an instance, but only if the socket does exist. This way, you can add 1,000 bullets to a mag that physically only could hold 30 rounds. So you could make like a guard mag, for example, or just a very rare one, and you would be limited to the physical size of the magazine. And before I forget it, go back to the get socket transform and change RTS world to RTS component. This is it for this function. The next function is going to be refill mag. This is more of a debug function. However, if you plan on using upgrades, for example, that refill all of your magazines, that's a function that you could use that for. So we want to get the max ammo count and then set the current ammo count. And then update all ammo instances. From the event begin play, call the refill mag function. Next, we want to be able to remove a single round. So let's create the function for it called remove single round. And here we get the current ammo count, and we want to check if it is greater than 0, because only then we can subtract another round and put that into a branch. If it is greater than 0, you can decrement the integer by 1, get the stored ammo, get instance count, and then check if this is less than the instance count. Because again, you could have a mag with 1,000 rounds, and if you still have 999 left, you don't want to subtract the mesh if there are only 10 rounds physically in the mag. If it's true, you want to remove an instance where we will get the instance count and subtract 1 from it. So we get the index of the last instance, and now we can remove it. And the function also needs a return mode, so select the function, add an output. I will call it was ammo removed. And here we want to return true. Even if this is false, we also want to return true because, again, this only checks if the current count is below the physical count of the bullets. If our current ammo count isn't greater than 0, we just want to add another return node, which returns false. And I almost forgot, very important, make sure that your stored ammo or your instant static meshes do not have any collision. So disable collision, can character step up on, no, and generate overlaps events, no. Because otherwise, since we're working with physics, this would interfere with the physics of the weapon, your hands, and the magazine itself. Now we're almost done. The last function we need is called add single round. Here we want to get the current ammo count and check if it is less than the max ammo count. And if it is, then we want to increment the current ammo count. Or we can just add 2 pluses and increment integer. Make this to true and update all ammo instances. And then we also need the return node. Hey, it's editing me here. I made a little mistake in the ammo container base. The logic that I implemented here was actually from the shotgun. So this is my fault. What you want to do is to delete the outputs. We don't need any outputs here. And on the branch, on the false output, we want to set the current ammo count to the max ammo count. Go to the event graph, call the begin play function. And from there, call the refill mag function. If we don't do this, our maze will be empty when spawned. Now that we have our ammo container base, we can right-click it and create a child blueprint class for it. I will call this BP_magazine base. This will be our base class for our magazines. Here we also want to add another static mesh. Static mesh. And I will call it carry mesh. This mesh is the carry which will push the rounds up, or at least it will look like it. In fact, we will just move it so it looks correct. Now, the carry mesh does not need any collision, so we can turn this off. Turn can character step up on to no, and disable generate overlap events. All we need here is one function. We will call it update carry position. And in this function, we will get the stored ammo, get the instance count, subtract 1 from it, so we get the index, and converted it to string, and then string append. And in A, we want to enter the first part of the bone name of our carry. So we will call it carry_bone_. And in B, we will input our index. Then we will get the mesh and check if the socket exists. So does socket exist? We can convert this to a name. Connect this to a branch. And if it does exist, we will get the carry mesh and set its relative transform. And for the relative transform, we will get the socket transform. The socket transform. The transform space should be component. And the socket name is our created name. Now what this will do, this will always set the position of the carry mesh to the last bullet. Then for this function to be called, we will override our previously created functions called refill mag, remove single round, and update all ammo instances. And all we do here is simply after calling the parent function, we will update carry position. And we can do this for all of these. I will just move this down here so it's a bit more visible. And here as well. There we go. That's it for the magazine base class. Then we will create another child class from the ammo container base. This one we will call BP_ammo box. This will be anything where we can pull bullets out of. So for example, a box filled with shotgun shells, or if you later want to add a revolver where you can put the individual bullets into the revolver, this would be the class we will be using. Now in our ammo box class, we will add a new variable, spawned ammo, and it is of type BP_ammo base. We want to remember our spawned ammo, because if you let it go in the air, we don't just want it to drop to the ground, we want it to return to the ammo box. Then the first function we will create is called take ammo. This function has two input parameters. The first is the character mesh, and it is of type skeletal mesh component. And the second input is the bone to attach to, and it's of type name. Then we also want to add an output. This we will call ammo actor, and it's of type actor. First thing we will do, we will get the spawned ammo, and we will check if it is valid. If it is valid, we just want to return null, because we only want to be able to grab one ammo at a time, because it makes it simpler and there will be less problems. And if it does not yet exist, we want to remove a single round, and we want to check if the ammo was removed. If a single round was removed, we want to spawn the actor for class, and here we will get the ammo class, which we set in our ammo container base class. Then for the transform, we can just split this and leave it as it is. And before we continue, if it's false, we just add another return node and return null. And for the collision handling, we always want to spawn it and ignore collision. Then if the spawned actor is valid, we are going to set it to the spawned ammo. Set spawned ammo. If it's not valid, add another return node, returning null. Then we want to set the owner, and we want the owner to be this ammo box. So we will just get a reference to self. Then after that, we can once again get this spawned ammo and attach it to component. Then the parent is going to be our input parameter, the character mesh, and the subname is going to be the bone to attach to. We want to snap the location and the rotation to the target. And for the scale, we can keep relative. Then get the spawned ammo again, and get the ammo mesh, and the shot ammo mesh. And set the collision response to all channels to overlap. If we don't set it to overlap, it will collide with the hand. And even if we weld the simulated bodies, it will constrain your hand's movement. Then we can add a return node and return our spawned ammo. That's it for the take ammo function. And the next function we're going to need is called clear spawned ammo. And here we will add a sequence and check if the spawned ammo is valid. If it is valid, we are going to destroy the actor. And on the second output of the sequence, we will set the spawned ammo to null. So then the last function we need is return ammo. Here, once again, we will get the spawned ammo. Check if it is valid. And just so you know, basically in blueprints, you don't always have to check if it's valid. Like your game isn't going to crash if there's a blueprint error, but it's basically force of habit because I usually program in C++, and if you don't check if something is valid, the program would simply crash. So if it is valid, we want to add a single round and then clear the spawned ammo. There we go. That's it for the ammo box class. Oh, I just realized, actually I want to use ammo box base. So we are consistent with the names. Now we can finally start with our projectile weapon base class. In our projectile folder, we want to right click, blueprint class, expand all classes and search for weapon base. And call it BP_projectile weapon base. First of all, let's disable the start with tick enabled. Oh, and actually I just remembered you can also go into the weapon base class and disable the tick there. Now first let's add the components. Let's add a static mesh, and call it slide mesh. We want to set its collision settings to grabbable object. And the next static mesh we are going to add is for the trigger. So let's call it trigger mesh attached to the weapon mesh. Now for the trigger, we can disable all collisions. And the next is the selector mesh, which is also a static mesh. And just like the trigger, we don't want any collisions for this one. Next, we are going to add a hitbox, or a box collision. This will be our magazine hit box. We will use this to know when the magazine is overlapping and when it should be attached. And always make sure that all of these components are attached to the weapon mesh and not to the last mesh you added. And next we are going to need a physics constraint. This we will call magazine constraint. We use a physics constraint because if we simply attach the magazine to the weapon, it is a bit weird with physics and collisions. We also need a second physics constraint, and this one I will call slide mag collision constraint. The only purpose of this collision constraint is for the slide and the mag to not collide with each other. And for both of these constraints, we can enable disable collision. And for the magazine constraint, we want to lock everything, so lock the rotation and the linear limits. And for the slide mag collision constraint, we want to set everything to free. Because again, this collision constraint is solely for the slide and the magazine to not collide with each other. I found this to be simpler than to give to everything different collision presets, which would complicate a lot of things and just clutter up our collision responses. Then for the magazine hitbox, we want to set the collision to custom, set everything to ignore except for the grabbable object. The grabbable object we want to overlap. And the collision enabled should be query only. So no physics collision. Next, let's create some variables. The first we are going to add is called current firing count, and it's of type integer. I will add to the category triple fire. We need this so we know how many times the weapon has already fired when our selected firing mode is set to triple fire. Then the next one is called max firing count. This one will get a default value of 3. So with this, of course, you don't have to only enable triple fire. You could say, okay, the weapon is only supposed to fire twice or 10 times. So you get a lot of freedom with this one. Then the next variables are for sound. First one is called mag in SFX of type sound base. And I will add this to SFX. Next one is called mag out SFX, firing SFX, trigger click SFX, slide back SFX, slide release SFX, and firing mode SFX. With this, you can set custom sounds for every movement your weapon does or your slide does when the mag is inserted or taken out, or simply when you're pressing the trigger. Next one is going to be the fire rate of type float. Here I will set the default of 0.1, meaning the weapon can fire 10 times per second. The next float is called last fire time. Then we are going to add the firing modes. This is an array of type firing mode, our enum that we added. And if you select the variable, come over here to the right and select this thing, you can change it to an array. With this array, we will set how many different firing modes our weapon can have. Here I will add a default mode, and it's going to be semi-auto, because I think that's what most weapons use. The next variable is called fire mode selector rotations. This is an array of type rotator, and here I will add a default value of 0. We use this because our rotator will look in different directions based on which firing mode. And with this, we can simply set the rotation to the same index as our firing modes. So we won't have to do some kind of calculations for every weapon. With this, we can just set the relative rotation of the fire mode selector. And to me, this seems like the easiest way of doing it. And the next variable is called selected firing mode. This is of type firing mode. And make sure to change this from an array to a signal. The default here I will also set to semi-angular. Let me just create categories for these, so this will all go into firing mode. The next variable is called matching magazine class, because we don't just want to attach any magazine that overlaps our hitbox, because then you could attach a rifle mag to a pistol, for example, which obviously we don't want. This is going to be of class BP magazine base, and we want a class reference. The next variable is called loaded magazine, and this is an object reference of the same BP magazine base class. And add these two to the category called magazine. There we go. Then we also want a reference to our loaded ammo, which is right now attached to the slide. So we call this loaded ammo. And it is of type BP underscore ammo base. It's an object reference. Next, we want to be able to set our slide travel distance. This is of type float. With this, we will set how far our slide can travel. This is very important. The value that you enter here has to be negative. You will see why when you implement the code. I will set the default value of, let's say, -5. But this has to be negative since this slide on most weapons that I know goes back. So in the opposite direction of where the weapon is facing. This is why we want to input this as a negative. And the next variable is called muzzle bone. This is of type name, and we will add a default value of muzzle underscore bone. I simply create this variable if we are ever going to change this name for whatever reason. I don't think we ever will, but just in case, we can change it in one place and don't have to search for it throughout our code. So it's nice and easy to change. Next variable is also of type name called loaded round bone. Compile and set a default value of loaded underscore round underscore bone. This is where our loaded round will be attached to the slide. The next variable is going to be our shell eject trajectory, and it is of type vector. Pilot, and here we will set the relative direction of where we want our shells to fly. For me, this will be to the right and up. So this will eject the shell in a 45-degree angle to the right. Now, of course, if you have a weapon, for example, like the P90, I think, ejects the bullets downward, you would only want the C to be -1 and the rest 0. But you can play around with this as much as you like. Then we also want to be able to set how forcefully the shell is ejected. So shell eject force. This is of type float. And I will give it a default value of, let's say, 200. And just organize a bit. This I will add to mains. I think the fire rate and all of this is, I think these are general enough to not be put into a category, or you could put them into a general category. I will leave them as they are right now. Next variable is going to be our muzzle flash, and it is of type Niagara system. Next, we are going to need a few bools. First one is was slide pulled. We will add this to slide. And actually, we can add the slide travel distance also to this category. And another one called was slide released. Is slide being held? Is slide stuck? And next, we are going to add some recoil stuff. So recoil distance. This is of type float. And I'm going to set the default value of -5.0. Here again, this has to be negative because the weapon is supposed to go the opposite direction where it's facing, which is why it should be negative. Next is the recoil pitch. This can be positive. I will give it a default value of 5 degrees. Then we also want another float variable called trigger max rotation. I will set the default value of -20. Here again, negative because the trigger goes downwards from a rotation perspective, which is why this needs to be negative. And we will use this to lerp the trigger based on our index trigger axis. And we just want to lerp between a minimum and a maximum. The minimum obviously being 0 and the maximum being, well, whatever we enter here. We are almost done. So next one is called primary hand. This is of type E controller hand. And the next one is the secondary hand. We want to apply different kinds of recoil based on how many hands are on the weapons. And both of these have a default value of any hand, because if it's any hand, it will mean that no hand is attached. For example, if the primary hand is set to the right hand and secondary is set to any hand, the weapon knows, okay, I'm only being held with one hand, so I can apply the full recoil. And if both hands are set, for example, primary right, secondary to the left, then we, for example, can divide the recoil by 4 and have less recoil. And the second last variable is called bullet count, and it is of type integer. We will set the default value of 1, because usually we want every weapon to fire exactly 1 bullet. This variable will also be used for shotguns, or if you have some special weapon, for example, like a full auto shotgun, which doesn't need the shotgun class in of itself, because our shotgun class will mainly be for pump action shotguns, or shotguns that have internal storage. Then you can also set how many bullets are supposed to be spawned through this variable. And we also want a max bullet spread, which is of type float, and has a default value of 10 degrees. With this, we will set a random rotation to the bullets, which should be maximum this amount of degrees. Okay, these were a lot of variables. Now next we are going to add a macro. This we will call check mag macro. Here we want one input called entry. It's of type exec. For the outputs, we want 3 outputs, all of type exec. The first one is called not attached, second one not empty, and the third one empty. In here we will get the loaded magazine reference. Check if it is valid. If it isn't valid, we are simply going to return not attached. However, if it is valid, we want to get the current ammo count. Check if it is greater than 0. Connect this to a branch. And if it's true, it's not empty. If it's false, it's empty. Based on this, we can then tell the slide to stay on the back and get stuck until the mag is released, for example, or if it can move back. So if no magazine is attached, or if the magazine isn't empty, the slide will automatically move back forward. Otherwise, it will get stuck at the back. Then the next macro we are going to add is the load round macro. Here we also want an input of type exec called entry, and 3 outputs. First one is called success, second one failed, and the third one mag empty. And at first we want to get the loaded demo, check if it's valid. Now if it's not valid, we want to check the mag, or we want to call the check mag macro. Now if it's not empty, we want to get the loaded mag and remove a single round. Now if that works, we want to spawn the loaded round. However, we don't have that function yet, so let's quickly add it. Spawn loaded round. Here we will need an input parameter of type ammo base, and we want a class reference. This we'll call ammo class. Let's add an output of type bool called success. Let's save this for now and come back to our load round macro. So if this is true, spawn loaded round. Here we want to get the ammo class from the magazine and input that. If this is successful, we will return success. If not, fail. And here, if the magazine is empty, we just return mag empty. And if it's not attached, we will return failed. And of course, if the single round couldn't be removed for whatever reason, we will also return failed. Now let's create a spawn loaded round class. Here, let's first add a branch and check if our class is valid. Because if not, we want to return false. However, if it is successful, we want to spawn actor from class. Here we will get our ammo class, and then let's get the slide mesh. Get socket transform. Here we will get the transfer of space as the world, and the name is the loaded round spawn. There we go. And we always want to spawn it no collision. If this is valid, we are going to attach the actor to component, the target being our spawned ammo, the pair being the slide mesh, and the socket name is the loaded round spawn. The location rule should be snap to target, so should be the rotation rule, and the scale rule we can keep world. Make sure world simulated bodies is checked. And over here, if the spawn actor isn't valid, we want to return false. After attaching our spawned ammo, we want to set the actor enable collision to false, because the loaded ammo doesn't need any collision. And then at last, we will set the loaded ammo. There we go. And return true. And the next function we are going to implement is called apply recoil. So first we want to get the owner and then cast it to our VR character. I had the issue that for some reason I couldn't cast to the VR character, or all you need to do then is get your VR character, right click, go to asset actions and reload it. Or closing and reopening your project should also work. I don't know why it didn't give me this node. But yeah, maybe it's just some bugging Unreal. Then from our casted VR character, we want to create a local variable called character reference. There we go. Then we will add a branch, and we want to check if the secondary hand doesn't equal any hand. It's not equal, and we want to not equal enum, so we actually get the name and not just number. We want to check if it doesn't equal any hand. Now, if it does equal any hand, we will go from the false output first. We will get our character reference and call the apply recoil function. For the hand, we want to get our primary hand, because again, if this equals any hand, it means we are holding the weapon with only one hand. Then for the location, we want to get the weapon mesh, get its forward vector, and multiply this by a double. So right click the pin to float double precision and get the recoil distance. And input this into the location offset. And for the pitch, we will just get the recoil pitch. However, if our secondary hand isn't any hand, so if you're grabbing the weapon with two hands, we first of all can duplicate this, connect it to the true output, and duplicate this again without the hand. Here we go. And for here, we want to get the secondary hand. And then we can also duplicate the offset. Just make some space. Yeah, this should be fine. And then we want to multiply this by another float. Here I will just add a value of 0.25, meaning the recoil will only be 1/4 of the main recoil. Then the recoil pitch, I will divide it by 2. So we also have less pitch. You can also divide it by 4, so you get the same reduction as up here, but it's not necessary. You can basically do whatever you want. And then for the apply recoil to the secondary hand, we only want to input the location offset and not the rotation. So the pitch is going to stay at 0. So this is it for applying the recoil. Next function is called eject shell. Here we want to get our loaded ammo. Check if it's valid. Now, if it is, we want to set actor collision enabled. Tick this to true. And here, once again, get the loaded ammo. And just to make sure, because sometimes it changes the collision profile and the physics simulation settings, from the loaded ammo, we also want to get the ammo mesh, since it is the root. Get ammo mesh, and set its collision profile name to grabbable object. Then we also want to set simulate physics to true. And then we want to add an impulse to the ammo mesh. Add impulse. Now here we want to tick the velocity change rule. And for the impulse, we want to get the shell trajectory. Rotate this vector by a rotator. Get the weapon mesh. Get its world rotation. Then multiply this rotated vector by a float, double precision, and get the shell eject force. Now you can input this into the impulse. Then after the shell has been ejected, we want to get the loaded ammo again and call the despawn ammo function. If you remember in here, we set the despawn delay with a default value of 5 seconds, meaning after 5 seconds after the shell has been ejected, it will be despawned. And after this, we can set the loaded ammo to null. The next function we are going to need is the load magazine function. In here, we want one input called new magazine, and it's going to be of type pp_magazine base. Then we want to get the loaded magazine and check if it is valid. Because we only want to attach a magazine if we don't already have one attached. Then we will get our new magazine parameter and check if it is a, in brackets, soft reference. No, only if it's not valid. And we will get our matching magazine class and connect it to the soft class. If this is true, we want to set actor location and rotation. And the target is the new magazine. And we want the location to be based off the magazine constraint. We'll get the magazine constraint and get the world location and the world rotation. And input this into the node. And also tick teleport. And next we want to get the new magazine's mesh. and our magazine constraint, and set the constraint components, where the mesh is component 2, and our weapon mesh is component 1. The bold names, we can leave this, no, we don't need any. Then if you remember, we also added a slide mag collision constraint, which is solely here to disable the collision between the mag and the slide. So here we also want to set the constraint components between the slide mesh for component 1 and the mesh of our magazine component 2. To that, we want to add a sequence where we first check if the new magazine's owner is our VR character. And if it is, we want to release the grabbed actor, the grabbed actor being the new magazine. After that, we can set our loaded magazine to our new magazine. Then set its owner to our weapon, so get the reference self. And after that, we can play a sound at location, the sound being the mag in SFX, and the location being the location of our magazine hitbox. Next, we are going to add the functions for ejecting the mag. The first is called init mag ejecting. If we simply eject the mag and call it a day, it will collide with our weapons and it will be a little bit buggy. So we first just want to disable all magazine constraint limits, have it fall out, and then actually break the constraint. First, we will get our loaded magazine, check if it is valid, get the magazine constraint, and set the linear X limit to 3, and do the same for the Y and Z limit. This again is just because the magazine would otherwise collide with the weapon and it would be a bit buggy. And we also want a delay between resetting the loaded magazine reference, because otherwise it will drop out, collide with the magazine hitbox, and will be reattached instantly. And after setting these limits to 3, we can set the owner of our loaded magazine, the magazine, to null, meaning it is no longer attached to the weapon, and then play sound at location. The sound being our mag out SFX, and the location being the world location of our magazine hitbox. Now, before we create the next function, I'm going to copy this and then create the next function called finish mag ejecting. And here first we will get the magazine constraint and the slide mag collision constraint, and break both of them. Then for our magazine constraint, we get our copied nodes from before, and then we will set all the linear limits to locked in. And at the end, we can set the loaded magazine to null. Now next we are going to add some slide functions. First one is being called is slide pulled. We want this to be a pure function. And in here we will get the slide mesh and get its relative location. Split this pin and check if the X location is less than or equal our slide travel distance, and we will give it a tolerance of 0.5, so add 0.5 to it, this to the second pin, and then add an output called is pulled of type bool. In here, we don't set our was/line pulled bool because this is simply to check if it is right now pulled. Then the next function is called is slide released. Here we also want an output of type bool called is released. And here we can go back to our is slide pulled function, copy this part, and check if this is greater or equal than our tolerance of 0.5 and return this. Our next slide function is called move slide back, because after a certain threshold we want to snap back. Here we also will get our slide mesh, set the relative location, split this structure pin, and for the new location X, and for the new X location, input the slide travel distance. This is also why this value needs to be negative, so it will automatically set the slide back, and we don't have to do any multiplication by -1 to invert it. Next, we want to check if the slide was pulled, and if it wasn't, we will set was slide pulled and set it to true. Set the was slide released variable to false, and play a sound at location. The sound being the slide back SFX, and for the location we will get the slide mesh and get its world location. And we need the was slide pulled variable to only play the sound once while moving the slide back. Since it's being checked every tick, while moving it, it would play the sound every tick, which we don't want. For the next function, we can copy the slide mesh and the set relative location node, because the next function is called release slide. Here we want to simply set everything to 0. So we can recombine the structure pin, save a little bit of space. Set the is slide stuck node to false, and then get the was slide pulled and the was slide released. We want to check if the was slide pulled is true and if was slide released is not true, and input this into a branch. Again, here we want to check if it was pulled but not released, because otherwise it will play the sound many times. But if that is true, we will set the was slide release to true, set the was slide pulled to false, and on our previous one we can get the play sound at location and input the slide release SFX. The next function is called load round. In here we will call our load round macro, and we'll add an output parameter of type bool called can release slide. If it's a success, we tick true. When loading the next round fails, we want to set the actor tick enabled to false, and then also return true. However, if the mag is empty, we want to set the actor tick enabled to false and return false. Here we set the actor tick enabled because we use the tick for full auto firing and triple firing, and we want this to be disabled when the next round cannot be loaded, so the weapon stops firing. Next, we will implement changing the firing mode, so call this function change firing mode. In here, get the firing modes and check if the length of the array is greater than 1. Connect this to a branch. Now, if it isn't greater than 1, it means that we only have one firing mode and we can just leave it. We don't have to do anything. However, if we do have multiple, we want to add a sequence, and then first get the firing modes and find the selected firing mode. This will give us the index of the selected firing mode in the firing modes array. First, we want to check if it does not equal -1, because -1 means the item has not been found in the array. If it's false, so if we did not find the selected firing mode, we want to set the selected firing mode to the first item of our array. So get the copy of the first item, so index 0, copy this. If we do find the item and it equals to the length of our array, -1 of course, so we get the last index, and subtract 1. So this gives us the index of the last item. If it is the last item, then our next selected firing mode should be the first item again. However, if it's not, then our next firing mode should just be an increment of 1. So we can get this, get the found firing mode, add 1 to it, because now we want the next index, and then get the item at this index. Then if we were able to change the firing mode, we want to play a sound at location. And this sound is the firing mode SFX. And the location is at the selector mesh. Get the selector mesh, get word location, and connect it. And we also want to do this down here, so just drag this up to this pin. Here we go. Now back in our sequence, after setting the firing mode, we also want to set the relative location of our selector mode. So set relative rotation of our selector mesh. And here we want to get our fire mode selector rotations. Get a copy of our found index of our firing mode. And connect this like this. We, of course, could also only set the pitch. If I split the struct, we could only set the pitch, but I found if we set it by a rotator, you can also have firing mode selectors that rotate on a vertical level or horizontal. You have a little bit more freedom doing it like this. Now we're almost done, but before we implement our firing logic, we are going to go to our class settings, over here to interfaces, and add our weapon interface. Because now in our functions tab, we can override the get slide component. And here we will simply return the slide mesh. Now our last function, the fire function. First, we are going to get our last fire time and our fire interval, or our fire rate, I mean. In the last video, we created the check interval function, so we will get that. And we will check if the weapon can fire again. So add a branch. Go. Also add an output of type bool. I will call it success. Return false if this is false. And up here, set the last fire time to the get time seconds. For that, we want to check if the slide is released. I just realized we also need to make this a pure function. There we go. So we don't have to input that many things. And also add a branch. Next, we want to check if the ammo is loaded. So loaded ammo. Check if this is valid. And we also want to check if this was shot at another branch. Now, if this isn't valid, add a return out, returning false. if this was already shot, we will also return false. So we can connect it like this. And we get the loaded ammo. And set ammo shot if the ammo wasn't shot before. Next, we will add a for loop. Make sure that it is a for loop, not a for each loop. Then the first index is index 0, and the last index is our bullet count. And subtract 1 from it to get the index. Or, of course, you can just, instead of, let's say, if you want to spawn 10 bullets, you only set 9, so you set the index. But I will do it like this. This, again, is so we can fire multiple bullets at once, like in shotguns, or if you want to add another kind of overpowered automatic weapon. However, we want the first bullet to always fly straight, that's being spawned. So we will check if this index is equal to 0 and add a branch. And we will get our loaded ammo and get the bullet class. And then we want to spawn active from class, back to the class. The collision handling should be always spawn and ignore collision. For the transform, we will get the weapon mesh. And here we will get the socket transform. For the socket, we will get our muscle bone. RTS world is fine. Input this transform. And set the owner of the spawned bullet to our weapon. Now we can duplicate this node and make the false input. For the class, we also want to get the bullet class. However, here we want to copy this and split the structure pin, because now we want to add some random rotation to the pitch and yaw. Get this and split the rotation. The location and the scale you can input directly. However, for the rotation, the roll can also be input directly. However, for the pitch, we want to add, and also for the yaw, get our max bullet spread, multiply it by -1, and then get a random float in the range. And this will be the minimum, and the maximum will be the max bullet spread. Duplicate this. I would love to just simply add the same output to both of them, but then you will get the same random value for some reason. And the randomness will only be about a diagonal plane in the world space for some reason. I'm not too sure why, but with this we will actually shoot the bullets randomly in any direction. Last, also set the owner of the spawn bullet. And here you can also see why we set the collision response of our bullets to pawn, so they won't collide with each other. Then if this is complete, I will move this out a bit so we have enough space. We want to spawn system attached. Our system would be our muzzle flash. The attached component will be our weapon mesh, and the bone will be our muzzle bone. Now for the location, we can get our weapon mesh, get socket transform, get the transform of our muzzle bone, then split the structure pin so we can get the location and the rotation. And the transfer space you can leave as RTS world. And we also need the location for next node, which is play sound application. And our sound would be our firing SFX. After that, we want to apply some recoil. So call the node apply recoil, and then add a sequence. First, we want to check if our selected firing mode does not equal single. And we also want to check if you're not holding the slide. So is slide being held? This is not cool. There we go. Because if our firing mode is set to single, it means you're holding, for example, a shotgun or a bolt-action sniper rifle where we have to manually load the next round. So if this is true, if you're not holding slide and our selected firing mode does not equal single, we want to move the slide back. Then we want to eject the shell and load the next round. Load round. If this is true, we want to set a timer by function name. The function name would be release slide function, and the time would be our fire rate divided by 2, because the slide would have to travel both ways. We don't want it to loop, and we can also leave this disabled. If it is false, we just want to set the is slide stock. We will set this to true. And here, if this condition is false, make sure to disable the actor tick. So set actor tick enabled false. Now, this is just a little bonus feature. I want, if the slide is stuck and you change out the mag, that you can press the trigger for the slide to be released. So back here, when we were checking if is the slide released, if it is false, we will add another branch and we will check is slide stuck. If it is, we want to load the next round. First, check if the slide can be released. If it's true, release the slide and return false. And also do this here, because returning false means we did not fire the weapon. Which reminds me, back here we added a sequence, and here we add a return mode, which is true. Great. That was a lot. I know it was probably quite boring. I'm sorry, but we are now done with the functions for the weapon. Now we can go into the event graph and add the rest of the logic. What we want to do first is in the begin plane, we want to get our firing modes. And we want to check if the size of the array is less than or equal to 1. Because if we only have one firing mode, that means that we do not need the selector. So if it is true, we can get our selector mesh, and we want to destroy it. Now in our event tick, this only runs when we are trying to fire full auto or triple. We will get our selected firing mode and check if it is equal to triple. If it is, we want to check if our current firing count is less than our max firing count. If it's true, we want to fire. And if this is also true, meaning the weapon has fired, we want to increment our current firing count by 1. So just search for increment int, and then you can increment it. If this is false, we want to set the actor tick enabled to false. Now here, if it isn't triple firing, it means we want to fire full auto, so we can just call fire. Now we can implement our fire function from the interface. So get event fire weapon, and every time we call this, we want to play a sound application. Here we will get the trigger click SFX, and the location is the location of the trigger mesh. So get the trigger mesh, get word location, and input that. Then we want to get our selected firing mode and add a switch. Now if it's signal or semi-auto, we simply want to fire. And when we press triple firing, we want to set the current firing count to 0 and set the actor tick enabled. And also set the actor tick enabled when we want to fire full auto. Then on our event stop firing weapon, we will get our selected firing mode. Because when we release the trigger, but we're in triple fire, we want the last few bullets to be fired of the triple fire. So for example, if you quickly press the trigger on triple fire, you still want the last 2 bullets to be fired and not only the first one. So we will check if this is equal to the triple fire mode and get the current firing count and check if this is less than the max firing count. Add an hand pool, a third input, and also check if is slide being held. And negate this pool. And then set the actor tick enabled to this value. Next, select the magazine hitbox. Right-click, go to Add Event for Magazine Hitbox, Collision, Add Component, Begin Overlap. And here we want to get the other actor and cast it to a BP magazine base. And if the cast was successful, we want to load the magazine. Then on our interface event change weapon firing mode, we simply call the change firing mode function. On the event release mag, we will init mag ejecting, add a delay of, let's say, 0.5 seconds, and then call finish mag ejecting. Next, we will implement the event move trigger function, get the trigger mesh, and set the relative rotation, Linus pin, and then add a lerp node for a float. The alpha is our alpha input, and B is the trigger max rotation. And input this into the pitch. This will lerp between the relative rotation of 0 and the max trigger rotation, which is also why we added a negative default value. So the trigger rotates based on how much you press the trigger on your controller. Next, we want to get the event start moving slide interface function. Here we want to first check is slide being held. If this is false, we want to set is slide being held to true and disable the actor tick. So set actor tick enabled to false. Meaning if you or if someone else grabs the slide of your weapon, the weapon will stop firing if it's in full auto. And for the event stop moving slide, here we will set is slide being held to false. Check if is slide pulled. Add a branch. If the slide was pulled, then call the load round function. Check if the slide can be released. If it's true, release the slide. And if not, check if is slide stuck. If it's true, release the slide. Because this means that the slide was already stuck back when we stopped moving the slide, and therefore it is no longer stuck. And if it is false, then it should be stuck now. So set slide stuck to true. Down here we set it to true because if it's false after trying to load the round, this means that we released the slide in the back, but the mag was empty. Therefore the slide cannot be released. Therefore we want the slide to stay in that position. And over here, if the slide is not pulled, we want to check if the slide is released. So is the slide released? And if it's false, it means it's somewhere between the pulled and the released position, and we just want to release the slide. You will see all of this in a second when we test it out. Now, our last function to implement is the event move slide interface function. First, from the motion controller, we want to get the world transform. And just a quick notice, this is how I got it to work. A lot of troubleshooting went into this because I wanted the slide only to move when the motion controller is actually where the slide is right now, or better said, the slide grip bone, which is our input here. And I had a lot of troubles with that. For example, when you grab the weapon too far ahead, you had to move your motion controller so far back that you couldn't actually pull it anymore. Or if you grab the weapon too far back, it would always move the slide back, but not into the front again. So yeah, this is how I got it to work. Maybe there's a better way. Again, I haven't really found a tutorial that used a full body with physics, and this is why I had to do a lot of troubleshooting. But this works, and you will see it in a second. So let's duplicate this and get the weapon mesh. We want to make the transform of our motion controller relative to the weapon mesh. So make relative transform and set this relative to our weapon mesh transform. Then we will split this up twice because we only need the X direction, which is also why we are working with the relative location, which in my opinion makes it a bit easier to work with. Next, we want to subtract the socket transform. So we will get the slide mesh. We want to get socket transform, RTS component space. Since we're in the event graph, we have to drag it out like this, which I know is a bit annoying, but it is what it is. So yeah, get that, input the socket. And here again, split this, split the location, and subtract this X value. Next, we want to get a clamp node. Clamp float. There we go. We want to clamp our value to a minimum value of our slide travel distance and the maximum value of 0. Because again, our slide travel distance is in the negative since our slide moves back. So we need this to be the minimum value. Now we can set the relative location of our slide mesh and split this new location pin and input our value into the X location. After this, we will add a branch and we want to check is slide pulled. If it is, call move slide back and call the eject shell function. However, if our slide isn't pulled back, we want to check if it is released. So is slide released? If it is, we want to release the slide. So, and then here, if you remember, we also play the sound. So it will snap forward after that 0.5 tolerance, and it will then play the sound. And if this is also false, it means that our slide is in between. So it's, let's say, halfway back, for example. So we will get another branch. We want to check if the slide was pulled. So was slide pulled. And if it's true, we want to check if the loaded ammo is valid. And if this isn't valid, we want to load the next round. Load round. Because again, if our slide was pulled, it means we are currently moving it forward. So the next round should be loaded. The next interface function are the event set main hand. I just realized we should rename this to primary. That's my fault, I'm sorry. The primary hand, although you can call it whatever you want. Set primary hand. Go and set this to primary hand. And here event set secondary hand. Set not this one, but we want to set primary hand. We want to set the property. We want to set secondary hand. There we go. We will get to calling these functions in our grab function in the VR character. There we go. That's about it for the event graph of the projectile weapons. Okay, I know, again, this was a lot. I am sorry. I tried to compress this as much as I somehow could, which is also why this video took so long to make. And additionally, that I'm trying a new way of recording it. But yeah, I've tried my best to compress this as much as I can. Now we only need one more class, which is the shotgun base class, which is a child class of this projectile weapon base. So BP underscore shotgun base. In here, we will add two new components. The first is a static mesh. We will call this latch mesh. And we also want an instanced static mesh for stored ammo, since some shotguns can store the ammo inside and others have a mag that attaches. And of course, everything should still be attached to the weapon mesh. For the latch mesh, make sure collision is disabled. So no collision, character cannot step on, and don't generate overlap events. Next, we're going to add some variables. Don't worry, it won't be as many variables as in the projectile weapon class. So the first one is of type bool, and it is called has internal ammo storage. And since I think it applies to most shotguns, it has a default value of true. A quick notice, I realized only after recording the video that I could have also created an actor component of the ammo container class and added this to this shotgun. However, I didn't do it for this video simply because I wanted to get the video out and I didn't want to delay it any further. I will create an actor component for this in the C++ version, which is also going to be an actual tutorial, like I said in a video that I've uploaded previously. This is more like an open source devlog where you can follow along and help me improve if you know some things better than I do. So basically, this is a prototype project, which works, but not everything may be done in the best way. So the next is also a bool and is called has latch. It also has a default value of true. And the next one is the current ammo count. This is of type integer. And we also need a max ammo count. I will give it a default of, let's say, 6. I don't know how much the average shotgun can store, but let's add 6. Then we need a matching ammo class of type pp_ammo base. And we need a class reference. This is like the mag for projectile weapons, where we want to check if the ammo that we try to insert and to store is correct. Then next is the latch rotation offset. It is of type rotator, and I will give it a default value of 20 for the pitch. Positive 20 and not negative because the latch, as far as I know, usually goes inside of the shotgun and not out. This is also a relative rotation. Then we also want a latch reset delay, and this is a float. I will give it a default value of 1 second, so the rotation of the latch will be reset after 1 second. And then we also want a ammo in SFX, which is a sound base. There we go. That's it for the variables. First function we are going to implement is called update all ammo instances. And here we can go to our magazines and ammo container base class. Like I said, I will create an actor component for this. So for now, we will just copy it, paste it. Then all we have to do is to replace the mesh reference with our weapon mesh. So get the weapon mesh and input it into there. The name of the bones are going to stay the same. And the next function is called move latch. We will get latch mesh. And we will set the relative rotation to our latch rotation offset. And then we will set a timer by function name. The function name is reset latch. I would copy this so we create the correct function. And the time is the latch reset delay. So we don't want it to loop. And now we can create the reset latch function. And in here, all we will do, we get the latch mesh and set the relative rotation to 0. The next function is called refill ammo. We will get the max ammo count and set it to the current ammo count. And then, of course, update all ammo instances. And I almost forgot, go to the stored ammo instance static mesh and also disable collision. Then we also want to be able to add a single round. So create new function, add single round, get the current ammo count, and check if it is less than the max ammo count. If it isn't, we're going to add an output called success, return false. However, if it is, we will get our current ammo count and increment it by 1. And then update all ammo instances and return true. Then we also want to be able to remove a single round. We want to get the current ammo count. Check if it is greater than 0. And if it is, we want to subtract 1 to decrement integer. This function, of course, also has an output. We'll also call it success. Turn false if this isn't greater than 0, meaning we cannot subtract another ammo. And then we want to get the stored ammo. Get instance count. And we want to check if our current ammo is less than the instance count. If it is, we want to get the index of our last index, so subtract 1 from the instance count, and remove instance at the last index. And then we can add the return mode and return true. The next function is called load ammo. Here we want to get the matching ammo class, and first we also want to add a new input called new ammo of type BP_ammo base. And we also want to check if is a soft reference to our matching ammo class. If it is, we want to add a single round. If this is successful, we want to play a sound at location. Sound is the ammo in SFX. And the location is the magazine hit box or location. Here we will use the magazine hitbox to also detect the ammo, since its collision settings is set to check for grabbable objects, and our ammo is also a grabbable object. Then next we want to get our new ammo parameter, and we want to get the owner, and we will cast it to the ammo box base. If it casted successfully, we will clear the spawned ammo, meaning if we let go, it will not be returned to the ammo base. And if the cast fails, we just want to destroy the active, which is our new ammo. Last function that we need to override the load round function, the load round function from the projectile weapon base. And in here before we call the parent function, we are going to check if the loaded ammo is valid. If it is valid, we want to return false. Now here we will add a branch. I did that, by the way, by just dragging it out and pressing B. And we will check if it has internal ammo storage. If it doesn't, we will call the parent load round function. And if it does, we want to remove single round. If this is true, we want to get the matching ammo class and spawn loaded round. And then we will add a return mode and get the selected firing mode and check if it is not equal to single and return this. This might seem a bit questionable why we check for the firing mode on a shotgun, but remember there are also shotguns that are fully automatic, that you have to pump yourself, that are semi-automatic, that have a mag, that don't have a mag. So this is why we do it like this. Now we can go to the event graph. Here in the begin play, we want to add a sequence. And to the first output, we want to add a branch where we check if the weapon has internal storage, ammo storage. If it does, we want to get the slide mag collision constraint and destroy the component, because there is no mag that the ammo could collide with. However, if it doesn't have an internal storage, it means that we want to attach a mag, meaning we will destroy the stored ammo. There we go. The second output, we will also add a branch. Here we will check if it has a latch. And if it doesn't, we just want to get the latch mesh and destroy the component if it's false. And quickly before I forget, up here, if it doesn't have internal storage, so if a mag can be attached, we also want to delete the latch mesh. Then from our weapon interface, we want to get event stop moving slide. And here, once again, we want to check if the selected firing mode equals single. Because if it does, we want to set this slide being held to false. And if it's not single, we just want to call the parent of the stop moving slide. So right click the event, go to add call to parent function, and connect it to the false output. And for the magazine hitbox, we also need to override the collision on component begin overlap collision event. Get this, check if has internal storage. It's true. And we want to check if the other actor is an ammo base. So no, not this one, but just to ammo base. There we go. If it is, we want to load ammo and move with the latch. However, if it doesn't have internal storage, we want to check if this is a magazine, so it has to magazine base, also the other actor. And then we want to load the magazine. Great, now we have all the weapon logic that we need. Next, we are going to add the new inputs that we need for our character. Let's go to our input folder, to actions, and I will add a new input action from input action. I will call it IA fire right. All of our actions are going to be a digital bool, so we can leave that as it is. I will duplicate this and call it fire left. Fire left. And duplicate it again and call it IA underscore release mag right. Duplicate it, release mag left. Next one is called IA underscore change firing mode right. And change firing mode left. There we go. Then we can set up the input in our IMC default. Let's add a new mapping. Here we are going to search for IA fire right. And the input should be the touch or trigger. Make sure to get trigger, not trigger axis. Next is the IA fire left. We'll as well get the touch L trigger. The next input, we want the IA change firing mode right. We want the touch or B press button. The IA change firing mode left, which is going to be the touch L Y button. And we press. And we want the IA release mag right, touch R A press. And lastly, the IA release mag left. Here we want the touch LX button pressed. There we go, that's our inputs. Next, we will implement our weapon interactions in our VR character. First, let's add some more variables. To our grabbing section, I will move the grab radius that we originally had in our character category. Then I will add a new bool called isRightMainHand, and another one called isLeftMainHand. We use these to know if our right or left hand is the one that is grabbing the handle of our weapon, and which we can use to pull the trigger or to change the firing mode. We're also going to add grabbable object types. This is of type eObjectTypeQuery, and we want it to be an array. In this array, we will add all of our grabbable objects. So here we will add an index 0 grabbable object. If you have other collision types that you want to be able to grab, you can add them here, simply by adding a new element and selecting it. I will also add this to grabbing. Now I will add a new variable called WriteWeaponInterface. This is of type EPI weapon interface. It should be only single, and we are going to add it to the category interface. There we go. And then duplicate it and call it left weapon interface. We need this so we can interact with our weapons without having to cast to it every time. Then in our functions for the grabbing category, we want to add a new function called trace for grabbable objects. I will move it to the grabbing category, and in here we want to add an input called motion controller of type motion controller component. So then we want to get the world location and do a sphere trace for objects. The start and the end is our motion controller component. The radius is our grab radius, and the object types are our grabbable object types. The rest we can leave as it is, and we will add an output called hit, and it's a type hit result. And then we will simply return our hit result. And in the beginning, we created a release grabbed actor function. So let's go in here. And if you remember, we only call this when we attach a magazine to a weapon. So we will no longer hold on to it. So first, we want to check if this equals our right grabbed actor. And if it does, we want to get the RPC, or right physics constraint, and break the constraint. And set the right grabbed actor to null. If this is not the case, then we want to get the grabbed actor and check if it equals to the left grabbed actor. You duplicate the break constraint node and get the left physics constraint, the LPC, and set the left grabbed actor to null. If it also isn't the left grabbed actor, that would mean something went wrong, and well, then we don't want to do anything. And I almost forgot, we also want to set this right main hand and set this left main hand to false. Next, we want to add our remaining weapon functions. So we'll create a new function called start ammo box interaction. And I will add it to the categories of weapons, weapon, then the straight line, and ammo. So it will create a subcategory. This function has 3 inputs. The first one is the motion controller of type motion controller component. The next one is the grabbed actor of type actor, and we want to pass this one as a reference. The last one is the bone to attach to. This is of type name, and we don't need this to be passed by reference. So first we want to check if the grabbed actor is valid. If it isn't, we want to trace for grabbable objects, and we will input our motion controller. Then we will break the hit result and check if the hit actor can be cast to an ammo box base. If it is an ammo box base, we want to take ammo, and we input our mesh, so get mesh, and the bone to attach to is our parameter bone to attach to. Then we want to get our grabbed actor parameter and set by ref var. Here we will input the ammo actor that we took. This is it for starting the interaction with the ammo box. The next function is called stop ammo box interaction. Also in the subcategory ammo. Here we only need one input. It is the grabbed actor type actor, and we also want to pass it as a reference. Check if it is valid. And only if it is, get our parameter. So the grabbed actor, and cast it to a BP underscore ammo box base. This is also true. We want to get the owner. I just realized I made a mistake. We want to get the grabbed actor and cast it to a ammo base, not the ammo box base, but the ammo base. Then get this owner and cast it to a ammo box base. There we go. Because if we stop interacting and the grabbed actor is still valid, this means that we did not insert the ammo into a shotgun, for example, and we are still holding it in our hands. Meaning, instead of just dropping it, we want to return the ammo. And then if we get the grabbed actor reference, we want to set ref var and set it to null. However, if the cast failed, meaning it doesn't have an actor, we simply want to destroy it. So destroy actor, and here we will get our ammo base. And also set the grabbed actor reference to null. That's it for ammo interactions. The next weapon function is going to be called check for slide. We will just add this to the weapon category. First, we need input of type actor. That's good. And we don't have to pass it by reference. Next one is the weapon interface. Type weapon interface. This one we do want to pass as a reference. Next one is the bone to constrain to, type name, and we don't need it to be passed by reference. And we need the physics constraint, so it's constraint component. We will pass this by reference again. And at last we want to get our motion controller, which is of type motion controller component, and it also doesn't need to be passed by reference. First, we want to create a local variable from the actor, then check if it is valid, so it's valid, and then add a sequence. We also need an output, type bool, and we will call it success, and we will return false if the actor is not valid. And I just saw I forgot to rename this, so this will be called hit actor. So for our first sequence output, we want to get the hit actor, get the owner, and we want to check if the owner is a weapon base. Because if it is, we are actually trying to interact, for example, with the magazine, which is attached to it, and then we would not be grabbing the slide. However, that's what we want. So we'll set the hit actor to our casted weapon base. So set hit actor. And then from our second output, we can get the hit actor, cast it to their weapon interface. And then we can get our weapon interface parameter that we pass by reference, set by ref_var, and set it to our casted interface. If the cast failed, we want to return false. However, if it's successful, we want to get the weapon interface, get the slide component, and then create another local variable called slide component. Check if it is valid. Is valid. There we go. And then we want to get the bone to constrain to. And so we don't always have to append the name together and only do it once in one single place. We will create a new function called get grip bone name. It will be a pure function and it will have one input called the hand bone name of type name, of course. Make sure this isn't a reference. Then cast this to a string. Get the string append node, connect it to the B input, and the first one should be grip underline. Because in our weapon, we will add sockets called grip underline hand R and hand dial. And with this, we can append it together and then return the full name. So return grip bone name. And connect this like that. There we go. Now back in our check for slide function, we can simply get grip bone name and create another local variable called grip bone to grab. And then we get our physics constraint, the parameter, and set constraint component. The component one will be our mesh. Look at the character mesh. The bone one is the bone to constraint to. Component 2 is the slide component. And the bone name 2 is the grip bone to grab. Next, we will get the physics constraint again. And here we want to set constraint reference frame. We want to set it for frame 2. And then we will get the slide component together with the grip component and get the socket transform of the RTS component. And then connect this to here. This will make that our hand is actually snapped to the slide. Then we can get our weapon interface and call the function start moving slide. And return true. That's it for grabbing slide. We'll also move this to weapon. The next function is called start weapon interaction. It's also in the category weapon. We want a grabbed actor of type actor, and it should be passed by reference. Then the next is going to be the weapon interface. That weapon interface. It should also be passed by reference. Next is a bool, which isn't passed by reference. And it's called is main hand. Because again, for any weapon interaction, we want to check if that hand is actually holding the handle or not. Then we want the motion controller of type motion controller component and the bone to constraint to, which is a name. And at last, the physics constraint of type physics constraint component. And this is once again passed by reference. So first we want to check if the grabbed actor is valid. And we also want to check if the interface is valid. So is valid interface. And we will add two branches. One to the is valid and one to is not valid. If our grabbed actor is valid, we want to get our weapon interface. And of course, if the weapon interface is also valid, we want to fire the weapon. Then we will add an output of type bool called success and return true if we fire the weapon and return false if the interface is invalid. Or down here, if the grabbed actor is not valid, but the interface is, then we also want to return false. If our grabbed actor is invalid and our interface is invalid, we want to trace for grabbable objects. Here we will input our motion controller. And by the way, these functions, we create them with this many inputs, so we don't have to do this whole logic once for right and the left hand. So with this, we have all the logic in one place, and all we have to do is input the correct right and left parameters. So then we want to break the hit result, get the hit actor, and cast it to blueprint shotgun base. And this is also something that I took a lot of time to figure out how to do, because on a normal weapon, you might want to interact with the slides by pressing the trigger, but on a shotgun, you want to be able to grab it and simultaneously move the slide. For example, then you can also do a one-handed reload, which is why here we have to cast for this shotgun base class. Then we will get the selected firing mode and check if it is single and add a branch. If it's true, return false. And if it's false, add a reroute mode by pressing R or searching for reroute node, and also connect the cast failed to it. And get the weapon interface and call check for slide. Now for the actor, we want to get the hit actor. Hit bone to constraint 2 is the power to constraint 2. This constraint is our physics constraint parameter, and the motion control is the motion controller. And here we will connect the return node to our success output. And here again, because I understand if you say that this doesn't really look clear what this actually does, we only go down here if our grabbed actor is false and our weapon interaction interface is also invalid. Meaning we trade for a new weapon, and let's say this isn't a shotgun, then we just want to move the slide. However, if it is a shotgun, we only want to move the slide when you are actually holding on to the shotgun. So when we are grabbing it with our second hand, unless, of course, if the firing mode isn't single, it means that it has a slide, because then it would be semi-automatic. And I have never seen a shotgun where the big pump action part of the slide also moves, unless I'm in the wrong, of course, which is why we return false, because then we don't want to grab anything of the shotgun. But yeah, that's this function. And the next one is called update weapon interaction. Here we have a weapon interface input, a weapon interface, which is passed by reference. And the next input is called is main hand, which is not passed by reference, is of type bool. Then we also need the motion controller, which is a motion controller component. The bone to constraint 2, which is the name and also not a reference. And the physics constraint, which is a physics constraint component, which again is passed by reference. Great. First we check if the interface is valid. And if it is, we also want to check if it is the main hand. So here's main hand. And if it is the main hand, then it means that it should not move the slide. So we just add a return node with a It's an output called success, hit bool, which is false. However, if it is, we will get our weapon interface and call move slide. Connect this to the false output. Input the motion controller. And the bone tool constraint 2. So again, this might seem a bit unintuitive, but with this, we will only move the slide. The hand will still be stuck in place for some reason due to the physics constraint, even though the slide and the hand components are constrained. But this, again, is another challenge of using a full body system instead of using 2 individual hands. Then we want to get the slide component, get the socket transform. This time we need to get RTS actor, mainly because since our slide is moving, we still want the relative offset to the origin of the weapon. And I just realized I made another mistake. Here we first want to get the grip bone name, and then we want to connect it to the slide grip bone. Then we can copy this and also use this here. Then we will get the physics constraint, and we will set the constraint reference frame. With this reference frame, you can move the constraint components after the constraint has been set. So we need frame 2 and connect this. Then we can return true. Again, I know not very intuitive, but this was the only way I really managed to make it work the way I wanted with physics, with a full body, because again, all the tutorials that I found online used individual hand components and not a full body. So this is what I had to come up with. If you do know of a better way of doing this, then please let me know in the comments. And the last function we need is stop weapon interaction. Here again, we will need the weapon interface. Which is also passed by reference. Then a non-reference bool. Hold this main hand. The grabbed actor. Type actor. This will be passed by reference. And at last, the physics constraint of the physics constraint component, which is also passed by reference. Then first we will check if the interface is valid. Valid interface. 1 second, I just remembered here in our update weapon interaction, if the interface is not valid, we also want to return false. My bad, I'm sorry. Now, if this interface is invalid, return false. So another output, bool, success, and false. If it is true, add a sequence, get the grabbed actor, check if it is valid. And if it is invalid, get the physics constraint and break it. In the second output, add a branch, check if it is main hand. If it is, get the weapon interface reference and call stop firing weapon. Have a return mode, which returns true. However, if it's false, then call stop moving slide. And set the weapon interface by ref_var to null. And then also return true. Here we set it to false because as soon as we let go while we were moving the slide, we don't want to move it anymore. However, if it's in our main hand, we still want to be able to fire the next time. Because if you would also set the weapon interface to null, then next time we try to fire, it will no longer find the weapon interface and it would not fire. Then we can also move the function into the weapon category. Great, now we can update our grabbing functions. Here in start grabbing, this is our last code, which is a mess. We are going to delete everything for now because there were a lot of things that I changed and that I realized could be done better. However, make sure you don't delete the output node since we are going to need it. First, we will add some more variables. Again, this function is just so we don't have to duplicate our code for the right and left implementation. So here we will add another physics constraint. We will call it other physics constraint. Type physics constraint component. I will move it up here to the other physics constraint, and we will also pass it by reference. Going to constraint 2, we can leave. Other grabbed actor we can leave. Motion controller is fine as well. Then we need a bool, which we will call is main hand. This bool we will pass by reference. However, the next, which we will call is other main hand, we will not pass by reference. So first what we will do, we will trace our grabbable objects. Then we will break the hit result, get the hit actor, and create a local variable called hit actor. Then we will check if it is valid. If it is not, we will simply return null. However, if it is, we will add a sequence. And in the first output, we will get the hit actor, get the owner, and we will cast it to weapon base. This is so when we are, for example, trying to grab a mag with our second hand that is attached to a weapon, we will grab the weapon instead and not the mag. And if this cast is successful, we will set the hit actor. And on the second output, we will get the hit actor again. We will get the root component, and we will cast it to a primitive component. If the cast failed, we will return null. However, if it didn't fail, we will create a new variable called component to grab and add a branch to it afterwards. Then we want to check if the hit actor is equal to our other grabbed actor. Here we cast to a primitive component because the root component of our weapons and any other mesh that we might want to grab, which might not be a weapon-based class, will be a primitive mesh. So we can still get sockets from it and know what to grab. So if this is true, we want to get another branch. And here we will check if is other main hand. If it is, we want to get our is main hand reference and set by ref var and set it to false. Then we want to get our hit actor and check if it is a shotgun by casting to it. So cast to shotgun base. Now if it is a shotgun and our selected firing mode equals single, then we want to get our hit actor, cast it to a weapon interface. And if this is valid as well, we want to check for the slide. There is again the hit actor. The bone to constraint to is the bone to constraint to. And here it is our physics constraint and the motion controller. Then if we are successful by finding a slide, we want to add a return node, which returns the hit actor. Because again, if it is a shotgun, then we want to grab it and also move the slide. Now if we come back here, to our shotgun, if the cast failed, we want to add a reroute node and route this to here and also connect the false branch. Now here we want to get the bone to constraint to, get the grip bone name and promote this to a local variable called grip bone to grab and connect it to this pin. I will move this forward because we will also need this if the check for slide is false. And we want to get our physics constraint and set the constraint components, where our component 1 is our mesh. Here we want the bone to constraint 2. Component 2 is the component to grab. And the bone name 2 is the grip bone to grab. We also want to check if the socket exists on the component to grab. So does socket exist? If this is true, we get our physics constraint. And we will set the constraint reference frame, where we will get the socket transform from the component to grab, get it transform, and here the transform space is RTS component. Connect this. And if it's false, we just want to return the hit actor. So if this grip socket doesn't exist, we will just grab the actor wherever our hand is. For example, if we grab the baseball bat and we didn't add this grip bone, then we will just grab it where our hand currently is. And up here, we will snap our hands to the bone. Also make sure to select frame 2 here, and then we can return the hit actor. Now we did the first part of this function. The next part going to be down here, so we will add a reroute node here. And then also set the isMainHand by refvar. Here the value is true. Connect it to this. And we also want to connect it if this is false. And if the other hand isn't the main hand, then this main hand should be the main hand. Then here we can copy this set constraint component together with the constraint, mesh, bone to constraint to, and component to grab. And then here, if the socket exists, so does socket exist? Here we will input handle bone. Here, this is now the part where we will no longer have to adjust the transform of our weapons, just so it sits correctly in the hand. This is now where we will use sockets, so we can set its rotation and location. We're going to branch from here. And we also want to get the socket transform from the component space. And here also the handle bone. If it's true, get the physics constraint and set the constraint reference frame, frame 2, input the transform, connect it to true. And if it's false, we just want to return the hit actor again. This up here is successful, we will also return the hit actor. Now we can go to our update grabbing function. This for one will be used for climbing, which will come in the next video. However, we will also need it for updating the shotgun slide position. For the input, we will add the grabbed actor, type actor. This does not need to be passed by reference. And the next is isMainHand, type bool, and the physics constraint. And before we continue here, I just realized once again that in here I made a little mistake. This other physics constraint, we don't need this. This was back from when I was testing stuff and I forgot to remove it. I'm sorry. So this is how it should look like. Sorry for the inconvenience. Now we can go back into update grabbing and add the rest of the inputs. So here the physics constraint component. This is passed by reference. And next we need the motion controller, type motion controller component, which does not need to be passed by reference. And at last, the bone to constraint 2, which is a name. Now first we want to check if our grabbed actor is a shotgun, so cast to shotgun base. If it is, we want to get the selected firing mode and check if it's single. because only then we want to move the slide. Otherwise, we will move the slide by pressing trigger. If it is, we will hit our shotgun class that we casted to. You cast this to a weapon interface. So cast to weapon interface. Then we also want to check if his main hand, because we only want to move it if we aren't holding it with the main hand. So if this is false, we will get our interface and call move slide. Here we will get our motion controller, and we will get our bone to constraint to, and input it into the function get grip bone name, and input that. And after starting moving the component, we want to get the slide component. Here we want to get the socket transform. Here we want to get the actor transform space, get the physics constraint, and set constraint and reference frame. Reference to, connect to transform, and connect it to that. Great, that's it for update grabbing. Next, we are going into stop grabbing. Here, this is from last time. Here we will need to add two new inputs. First one being the grabbed actor, actor. And we will pass it by reference. The second one is the other grabbed actor, which we do not need to pass by reference. And then we want to check if they are not the same or not equal. The branch. Now, if it is true that they are not the same and our grabbed actor is valid, because it could be that they're both null when we release, then we want to set its owner to null. Because if they are the same and this is not null, this would mean that we are still holding the weapon in our other hand, and then of course we don't want to set the owner of the weapon to null, only if we are no longer holding it. Now we can switch into the event graph and change our grabbing logic in here. Actually, before we change this, we will implement the interacting logic. So first we will get the IA by right. From the triggered output, call update weapon interaction. And then here we want to get the right weapon interface, the is right main hand, the motion controller, the RMC, I mean. For the bone to constraint to, we want the hand online R. And for the physical constraint, we want the RPC. And if we've started interacting, we want to call start interaction. And for complete stop weapon interaction. Here the grabbed actor is the right grabbed actor. The right weapon interface is right main hand. Bone to constraint to is again the hand R. Motion controller is the RMC. And the physics constraint is the RPC. So if it is not successful, call start ammo box interaction. Input the RMC, the grabbed actor, right grabbed actor, and the bone is the ammo online bone underlined car, which is the one that we set up on our thumb. Then for the stop weapon interaction, again we'll get the right weapon interface, is right main hand, the right grabbed actor, and the RPC. Great, I will move this out of the way a bit so we have enough space. Actually, I will move it over here because we will need some space for the grabbing part. And now we will do the same for IA underscore fire left. I won't show you this. I will just speed it up substantially because, I mean, all you have to do is just instead of right, you will input left. And here, make sure you change hand R to hand L. And here, ammo bone R to ammo bone L. So yeah, I will do this quickly and then I'll be right back. Hey, it's editing me again. I once again forgot another part. Here on the stop weapon interactions, we need another branch. And if this is false, we want to get the right grabbed actor and call stop ammo box interaction. This somehow slipped my mind, and while testing it, I asked myself why it just wouldn't work. Yeah, sorry, this is on my part. And here we want to get the left grabbed actor. There we go. Next, we will implement changing the firing mode. So we will call IA change firing mode right. Get this right main hand. We want to add the branch to the started output. So if it is the right hand, we want to get the right grabbed actor. And we first want to check if it is actually valid. And if it is, we also want to check if the right weapon interface is valid. If it is, then we want to change weapon firing mode. Right now again, I will speed up the video while I duplicate this for the left hand. Now what we can do for releasing the mag, we can copy this, except for change the weapon firing mode. Just down here. And here you get the IA release mag right. And it's started to it. And IA release mag left. Also connect the started output to the branch. And here call release mag. That's that. Now the last part is updating our grabbing logic. So here I will start by making some space because we will need it. So just move this down a little bit until it should be fine. And now let's start connecting things. So get the right grab actor, the is right main hand, the RPC, and for the motion controller the RMC. The input is the hand R. Then this one, we want to move it back a little bit. Actually, I will disconnect this. Now move this back a little bit. This down. And from the started output, let's first get a is valid node. It seems like my PC is slowly giving up, but we will push through it. Check if the right grab actor is valid. And if it is not, we first want to check if the right weapon interface is valid, because we could be interacting with the slide right now, which doesn't set the right grab actor, meaning we don't actually want to be able to grab. So here we will check if it is a valid interface and the branch, and connect if it's not valid to it. And if this is also not valid, then we can do our trace. Here, the ball to constraint tool we can leave on hand R. The other grab component should stay the left grabbed actor, physical constraint RPC, motion controller RMC, and here we will get is right main hand and is left main hand for the other main hand. Now here in the back, after setting our right grabbed controller, we want to cast it to a weapon interface to check if it does implement this interface. You also want to check if this hand is the main hand, so is right main hand, because remember in the start grabbing function we do set the value of is right main hand. Then add a branch. If it is the main hand, we want to first of all set the right weapon interface to the casted interface, and then call set primary hand to the right. And if it is false, we want to call set secondary hand to the right. And that's it for starting to grab. Now I will move this out of the way again. Actually, you know what? I will delete this because we can just copy and then change everything from right to left. Down here, we can also get rid of that. However, before I do this, otherwise I have to expand this. I will get an is valid node. Here we go. Now, in this, can drag it down to here. Actually, down here should be fine. We will check if the right grabbed actor is valid. And if it is, we want to get the is right main hand. Check if this is true. This is also true. We want to stop grabbing. For the physics constraint, we want the RPC. The grabbed actor is the right grabbed actor. The other grabbed actor is the left grabbed actor. Then after that, we will set the right grabbed actor to null. Then the his right main hand to false. We will get the right weapon interface and check if it is valid. Now, if it is valid, we want to stop firing, because if we are firing a weapon in full auto and just let go, it would continue to fire until it is empty. So stop firing weapon. And then also make sure to set the primary hand to any hand. The weapon now also knows that it is no longer being held and won't apply any recoil anymore. And we can add a reroute node for this, and then set the right weapon interface to null in both cases. Coming back to here, if the right hand isn't the main hand, we want to drag out another branch and also check if the weapon interface is valid. Now, if it is true, we want to cast to shotgun base, and the object is our right grabbed actor. We will add a reroute node, and then we will call stop grabbing. And just as above, we have these three inputs. And let's connect these. And here it might not seem very intuitive why we cast to a shotgun. However, because remember, this is only set or only true if our main hand isn't the right hand, if we're holding a shotgun. And after this, we add a sequence. We will get the right grab actor casted to a weapon interface, because again, back here, the interface may have been false, and then set the secondary hand to any hand. And then we will set the right grabbed actor to null. Okay, now give me a second. I will copy this to the left hand, and I'll see you in a second. Great. Now that that's done, the last thing we need to do is to move the trigger when we press our index finger. So over here, we want to get the right weapon interface. Check if it is valid. Actually, I will move this a bit out of the way. We have enough space. There we go. And then we will get the right weapon interface. Call move trigger. And when this is true, And for the alpha, we will get the right index value. Now, of course, we can just copy and paste this to the left index. And don't worry, I know right now there aren't any comments, but in the prototype project that will be available for download, I will add comments so you know what is where and what does what. So it's a bit easier for you to read it. Get the left index value. There we go. Now the last thing we need to do is to apply the recoil offset to the hands in our animation blueprint. So go to the VR character animation blueprint, open it, and then in our set MC transforms function, in here from the VR character, actually, you know what, I will organize it a little bit. Here we want to get the right recoil offset. And we want to add this value to our location. Now we will do the same down here. We'll get the left recoil offset and add it here. Great, that's that. Okay, now that we have set up all the logic, now we can start importing our meshes. So in our content browser, I will add a new folder called meshes. The first weapon I will import is going to be the pistol. So let's create a folder for that. Then import. Now to import the things when importing the meshes, select static mesh and make sure combine static meshes is unticked. Also go ahead and search for nanite and disable build nanite, because we disabled it in our build settings, and if we leave this disabled, it will make our meshes look weird. Now we can import it. I will leave the link to the original assets that I've used. However, just note that from those assets, I took them apart. So we have an individual slide mesh, magazine, shell, trigger, bullet, carry, and one that I still need to import because I imported it as a separate mesh is the pistol ammo. They are all included in the prototype project, but if you want to do all of this yourself, then you can, of course. Just make sure that the origin of the slide is actually at the location of the weapon. Because if you recall, we set the slide only through its relative location. And if you have to move it first, it may no longer be at the correct position. Let's start with the slide. I will first add all necessary bones and then the optional one. So you get the most important one first. So in the socket manager, let's create a socket and let's call it loaded underscore round underscore bone. Here in the advanced tab, we can add a preview static mesh. So let's add the shell for our bullet. Bring this in. And now we can position this where we want it approximately to be in the slide. Meaning if we pull the slide back, this is where we see our mesh. Don't worry, you don't have to clear this. This won't be visible. This is purely in this editor, so you won't have to remove it again. This seems approximately right to me. Then we also need two other sockets. These are the grip sockets where our hand is supposed to be. First one we will call grip underscore hand underscore R. Maybe you recall we created that function which will append hand R to the grip underscore string and return everything as a name. This is why. So we can set the hand location on the weapon. And for the location, I will put it in the back. Actually, here I will use the coordinates from my test project, which is this exact same project, just where I test things out first. And if you would leave it right now like this, the thumb would look upward and the hand would look to the front, which we don't want, of course. We want it to turn a bit, meaning we need to add a rotation, which here would be plus 170 for the x-axis and the z-axis. Then we can simply duplicate this and call it grip underscore hand underscore L. And here the rotation is 90 and also 90. There we go. Now you can save this. Then the next is the body. Here the first socket is going to be handle bone, or handle underscore bone. This is where we hold the weapon. Now, this is at the correct location for this weapon, because when I first took it apart, I still had the whole system where I used the weapon's origin as the point where I wanted to grab it. So I can leave the handle here. Of course, you can always adjust it if you like to. And the next bone is the muzzle bone, muzzle_bone. Of course, you can choose different names, but just make sure to also change it in the logic that we've implemented, where we've used the same names. Approximately try to get it in the middle. Should be about here. And here we also want grip bones. So add another bone called grip_hand_arm. Here I will use the coordinates -2 and -5. And for the rotations, we will use 60 and -45 degrees. And we can duplicate this again. Call it grip hand L. And then invert the rotation. Location should stay the same. There we go. That's all the bones we need for this. And then here I would recommend you, if you go to show and select simple collision, now you can see the weapon has somewhat of a weird collision. You can also reset the collision. For example, delete this and then add a box collision and set up the collisions. Or in things like the trigger, for example, which shouldn't have any collisions, I also delete this and leave it without collision, even though we set it in our blueprint class, but I'll just like to be safe. There we go, that's approximately good enough. So if we go to trigger, you can see its origin is where it should rotate. And here we can just remove the collision. I will close these tabs because my PC is starting to give up. Next is the magazine. Here I first again will add the handle bone, and I will add a rotation of 345 degrees. So you can see if we hold it now, the magazine will be straight in our hands. Otherwise, it would be still leaning forward and it would look weird. And now the next step is optional. It's only if you want your bullets to be displayed in your magazine. And besides the whole code implementations, which got pretty complex in this video, this is also why I give the prototype project to you for free, because this is a lot of setup, which I will show you now. So for our bullets, we want them to spawn based on how many bullets there are. So we will create a new socket and call it ammo_bone_0. The number at the end is the index. If you remember in our implementations where we update all ammo meshes, this is also where we append the index to the ammo bone string, and then based on that, add an instance or remove it. So here I will also add a preview mesh. Here I will add ammo, pistol ammo, so you can see how this sits in here. And since the index 0 is at the top, I will add this bullet here. Then I will duplicate this. I don't know why it doesn't just increment it by 1. This is very annoying, but well, it is what it is. Then I will take this duplicated one and move it down here. So you can see with this, you can decide yourself where the bullets should be. And as you can see, this magazine has holes in the back, so you will be able to physically see how many bullets are left. And duplicate it again, set its name to index 2, and move it to the other side, and so on and so forth. I'd say for most projects, this would already be enough, or maybe one more, since you're probably not going to see the ones below, again, unless you have these holes or if you have a translucent magazine. In the prototype project, this magazine is filled. Every magazine will be physically filled with bullets, but here I will leave it like this. It is just to show you how it is done. Then for the carry, we will add another socket called carry_bone. And the first one will be _-1. Because if you remember, we will set this index based on how many bullets there are. Here I will get the carry for the preview mesh and then add it somewhere where it should fit, where it is at the top. Say, it's a bit high. No, this should be fine. Next, I will duplicate this again. This time it's the index 0. And I will move it down slightly. You can see if you clip into it, you can actually see where it is. I will line it up with the bullet. And from here on out, I will only add every second index. So next is 2. I will move it down. Since you can see the carry mesh has 2 indents for 2 rounds. I'll move it down to here. That's fine. Move it into the mesh so it's not clipping outside of it. And we check back here that it's lining up properly. And this will be fine. Again, you can fill the whole magazine with that. And then every time you will move a single instance of this mesh, and you will also set the carry and it will move one position up. It's for every magazine the same. Now I've set up the rest of the meshes. This is also important for your pump action shotgun. If you have a mesh of a shotgun that has an internal ammo storage, you of course will also need to add the ammo bones to it. So you can see we have the muzzle bone and we have the handle bone. And here, of course, it is tilted a little bit because the hand isn't supposed to just be straight here. And you can see here are no grip bones on the shotgun. This is because if we grip it, we will always grip it on the slide. So if we go to our slide, you can see here, for one, we have our loaded round bone and we have our grip bow for the right and the left hand. And if I go to the ammo pack, this is the ammo box for the shotgun shells. You can see here it is exactly the same. We have ammo bone 0 up to 9 because there are 10 rounds that fit in here. And then based on how they're ordered, so first the ammo bone 9, the shell at index 9 will be removed, then 8, 7, 6, and so on. And I've also added a rifle. Here, once again, it is the exact same as for the pistol because they both belong to the projectile weapon class. You have your grip, you have your muzzle bone, you have your handle bone, and on the slide, you have the bone for your loaded round and the grip hand bones. And I would share this with you. However, I'm doing this in Unreal Engine 5.5, meaning even if I upload these like they are right now, they're only available for 5.5, which at this point I thought, well, I might as well just upload the whole project. Because this way you can still watch the tutorial, still learn how it works, but you already have a finished project which you can pick apart and test out. Or of course you can take the meshes from the project and copy them into your project. Great. Now that we have all of our components, we can start creating our weapons. So let's start with our bullets. First, we will create a child blueprint class from our bullet base, and I will call it BP_pistol bullet. First, let's set up the bullet mesh. Come over here, search for pistol bullet. And our bullet needs to have a collision. A simple sphere collision would be fine as well. I didn't change it here. And then in your projectile movement, you can change its speed. So for example, the initial speed. Just make sure that the velocity always points toward X. And then of course, here we have all our other variables. For example, the damage, the lifetime, and the impact particles, the impact sound, and the impact decals. Just to not artificially make this video any longer, I will not set these. You can literally take any kind of particles, put them in here, take any sounds, put them in here, and any decal, and put it in here. Don't worry, this will be set in the prototype project that is available for download. Then here in the ammo, we create a child blueprint class of this, BP_pistol ammo. Then in here, we want to go to the details panel and select the bullet class. Here is the pistol bullet. You can set the despawn delay. Wall shots should remain false. We shouldn't change this. Then for the ammo mesh, we will choose the pistol ammo. And for the shot mesh, we will choose the shell mesh. Shell mesh from the pistol. That's it for the ammo. Now we can come up here to the magazines and create a class, a child class from the magazine base. Let's call it BP_pistol magazine. Our pistol is supposed to have 17 rounds, and the ammo class will be our pistol ammo. For the mesh, we will get the pistol mag mesh. And for the carry mesh, we want to get the pistol carry mesh. You can leave this where it is right now. It will be set after begin play. This is very important for the stored ammo. Make sure to also set the pistol ammo mesh, because otherwise, if we add instances, it doesn't know which mesh to add. Great, and now let's test this. I will create this out. Now, if we simulate, you can see the magazine is filled. Next, we want to set up our first gun. So in here, right-click the projectile weapon base, create a gel blueprint, call it BP_pistol. Now in here again, over here on the right, you can set all of these sounds as you like. They will be set in the prototype project. Fire rate we can leave because this pistol will only be single fire, but it will be semi-automatic, so we don't have to change the fire mode, select the rotations, or the firing modes itself, or the selected firing mode. However, we will need to set the matching magazine class. So we want the pistol magazine, and the shell eject trajectory is also correct. The force is fine as well. Again, muzzle flash, you can set that yourself. Now the recoil distance, very important. To be able to set this, we need to first add the meshes. So here we want the pistol body. Then we don't have a selector mesh, that's fine. This component will be removed on begin play. The trigger mesh, trigger of the pistol. Now we can move it to a matching position. And let's say around-ish here. Maybe up a little bit, there we go. And now you can also rotate it, so you can see at like -25, I'd say is as much as we want it to go. So you take that measurement, I guess, you can call it, and trigger max rotation is -25. Then of course also make sure to add the slide. Let's do slide. And now we can move this back. I will enable the grid and snap size 1. So 1, 2, 3, 4. I'd say at about 4-ish is good. So make sure to reset this position to 0. I think before I said the recoil distance, no, of course what I meant was the slide travel distance. So after setting our slide, then here in our slide travel distance, set it to -4. Then for the recoil, you can set whatever. I will leave it at -5 and a recoil pitch of +5 because pistol in of itself doesn't have that much recoil. And then all we need to do is to select the magazine hitbox, scale it down to, let's say, 0.03. Move it down a little. Okay, we'll turn off the snapping. And move it where you want the magazine to be loaded. So I'll put it around here. Speaking of magazine, it will be attached to our magazine constraint. And here I recommend getting the slide. So if you go to the pistol, get the magazine static mesh and connect to the magazine constraint, because now you can move it around, match it up with where it should be. For the pistol, this is at 0, and after you're done, you can just delete the magazine mesh and you're all good. This is solely to set up the location where the magazine should be attached. For the pistol, again, it's just in the handle, which is at the same location. But if you have a rifle, for example, where it's in the front, then there you would need to move the magazine constraint. Again, this is all set up in the prototype project. Now that that's done, let's drag out the pistol and projectile pistol. Don't worry about this big collision box. This is from the penetration logic, but since our pistol is a blunt weapon, it will be destroyed. Then we also want to get a magazine. And now if you simulate this, you can take the pistol, move it to the magazine, and it's in. However, you can see that, for example, if you try to grab the magazine, this, by the way, only happens if you do it like this. In VR, this won't be a problem. And you move it here, you can see the pistol starts moving, but that's not because of the magazine or because of collisions. This is simply because you were still holding on to the magazine with this. They are constrained by a physics constraint, therefore it's basically physically connected to the pistol. But the pistol can still move and everything, so it's, yeah, if you run into this, don't worry, it is only because you're moving it with the mouse. In VR, this is no problem. Great, now that's the pistol. For the rifle, it's basically exactly the same setup. I will also set up the ammo box and the shotgun for you, and then the rifle, like I said, is the same. And again, all of it is available for download. So next, right-click shotgun base, create a child blueprint class, pp underscore pump action shotgun. Open it, and our shotgun is supposed to have an internal ammo storage and a latch, so we can leave these. For the max ammo count, we are able to store 7. Matching ammo class, oh right, of course, we need to set that up first. Magazines, ammo, bullets. Create a new bullet class, pp underscore shotgun bullet. Now here for the bullet mesh, I will simply choose a sphere, and you want to choose one that has the origin in the middle. There we go. I'll set its scale to like, actually smaller, 0.01, because shotgun usually fires many little pellets. Let's see if there's an emissive, emissive color, the yellow one, so you're able to see it better. And the rest I will keep as it is. And in the ammo base, we will create ep underscore shotgun ammo. And here the ammo mesh is the shotgun shell, and the shot ammo mesh is the shotgun shell shot. Now this is hidden, of course, so we won't see it, but you can scroll down a little bit and turn on visibility. You can see it's the shot mesh. I'm sure to disable visibility for that one again. And then in here, we also need to set the bullet class to shotgun bullet. Then in the magazines class, we want to create a child class of our ammo box. So bp underscore shotgun ammo box. Here get this mesh. Oh, and by the way, I didn't add a handle bone to this because otherwise the hand would clip inside of it, or it would have to be on the side, of course, if you still want that. But with this, you can just grab it anywhere. And then this for a stored ammo, make sure to select the shotgun shell. Then max ammo counts, we can leave it at 10. The ammo class is the shotgun ammo. And now in our pump action shotgun, the matching ammo class is the shotgun ammo. The latch rotation offset, we can leave that. Fire rate doesn't matter because, well, it's a shotgun, it's not full auto. Now the recoil distance, I will give the recoil distance of -20 and the recoil pitch of, let's say, 10. Now we can start adding the meshes. First the body, then the latch. Since this is a rotating component, its origin is at 0. So we can just move it up here. And then you can see if it turns 20 degrees, this is about fine where a shell would fit in. Go. If you're setting up the rifle, make sure to also set the selector mesh. And if you scroll down, we set up our fire modes. Then you would need multiple fire modes. And in here also adds a rotation. Usually we set the rotation by the pitch, but of course you can rotate the selector in any direction you like. So next would be the trigger mesh. Let's put that around here. See how far back it can go. Okay, I think like 30 is enough. Trigger mesh distance maybe is 30. And of course the slide. Go. Now let's see how far back this is supposed to move. 1, 2, 3, 4, 5, 6, 7. Yeah, about 7 seems good. Shuffle distance and input maybe 7. And of course the magazine hitbox. Let's scale this down to 0.3. Move it where the shell are supposed to be inserted. And of course let's lengthen it a little bit. There we go. That seems about right. And at last, here we have our bullet count. Right now it would only shoot 1 bullet. Let's change this to, let's say, shoot 10 bullets at a time. Max bullet spread, you can change this. I will leave it at 10 degrees for now. Another thing that's very important that I only realized while editing and testing the logic, in the shotgun base, since most of the shotguns that I personally will be using are pump action shotguns, make sure that the selected firing mode is set to single and not semi-auto. This goes for the selected firing mode and also for the firing modes. And that's the shotgun. One thing I just remembered, which you might want to do, if you want, for example, to create a magazine that has more bullets that just lays around in the world, if you go to magazines and your ammo container base, in our variables, the max ammo count, you can make it a public variable. And what this means If you select it, you can see you can now set the max ammo count. So for example, let's duplicate this and set the max ammo count to 1000. Don't set this too high since we have for each loop. The blueprints will say that it's detected in the infinite loop. This doesn't happen in C++, but blueprints sometimes can be a bit annoying. And then here, let's change this to like gold if we have something. Yeah, there we go. And now we have our golden 1000 round mag. And yeah, this is about it. As of right now, we are still using the procedural hand animations to grab the weapon. So the trigger finger won't always align with the trigger. This is something that I will cover in a future video on how we can add custom hand animations for our weapons. Thank you so much for watching all the way until the end. I know this video was very long and tedious. In the next part we will be implementing a climbing system with sliding mechanics. I cannot tell you yet how long this is going to take, but I will try to create the video within 3 weeks. I am currently a bit short on time because soon I have to write some final exams, but I will be in full swing again after June. If this tutorial was helpful to you, make sure to leave a like and subscribe. Let me know in the comments if you need any help, and I will see you next time. Bye!